check. 1, 2, check. check.
The lunch is at 12. Oh, sorry, the break is at 12, 12:15. Yeah, something around that time. It's about what they are saying. Hello. Yes, عم بتكلم محمود. Can you hear me? Is my mic? Okay. نعم. ايوه ايوه شايف اوكي.
Check, check, hey, check, check, hey, check, this, hey, check, hey, check this, hey, check, hey, this, hey, check, hey, check, hey, check this, hey, check, hey, this, check, hey, this, hey, check, check, hey, this, hey, hey, check, check, hey, check this, check, hey, check, hey, hey, check, hey, check, check, hey, hey, check, hey, check, hey, check, this, hey, check, hey, check, check, hey, check, hey, check, hey, check, check, test, check, hey, check, hey, check, 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 check.
بسم الله الرحمن الرحيم. معالي الدكتور خميس بن سيف الجابري، رئيس وحدة متابعة تنفيذ رؤية عمان 2040، راعي حفلنا الكريم، أصحاب السمو، أصحاب السعادة، ضيوفنا الأفاضل، السلام عليكم ورحمة الله وبركاته. يسرنا أن نرحب بكم في النسخة الثالثة من مؤتمر عمان للكهرباء والطاقة IEEE PowerTalks، الذي ينظمه معهد مهندسي الكهرباء والإلكترونيات IEEE بالتعاون مع شركة رايا للخدمات، وتستضيف فعالياته مجموعة نماء. ونستهل حفلنا بآيات عطرة وتلاوة مباركة من القرآن الكريم.
الله لا إله إلا هو الحي القيوم، لا تأخذه سنة ولا نوم، له ما في السماوات وما في الأرض، من ذا الذي يشفع عنده إلا بإذنه، يعلم ما بين أيديهم وما خلفهم، ولا يحيطون بشيء من علمه إلا بما شاء، وسع كرسيه السماوات والأرض، ولا يؤوده حفظهما، وهو العلي العظيم.
بعد هذه التلاوة المباركة نود أن نعبر عن عميق شكرنا وتقديرنا لشركائنا الذين كان لدعمهم المستمر دور أساسي في نجاح هذا الحدث المميز. ونخص بالشكر هيئة تنظيم الخدمات العامة على دعمها الكبير، وشركة تنمية نفط عمان على دورها البارز في إنجاح هذا المؤتمر. كما نتوجه بالشكر الجزيل للشركات الراعية التي ساهمت رعايتها بشكل رئيسي في تحقيق هذا النجاح، وهي فولت أمب إنرجي، هيتاتشي إنرجي، سيمنز، فينيكس باور، مرافق، سوجكس، زواوي باورتك، حمد للخدمات الهندسية، ABB، يونيكورن، وكابلات عمان. ولا ننسى جهود أعضاء اللجنة الفنية الذين عملوا بجد على مدار الأشهر الماضية لإعداد برنامج فني متكامل، واختيار المتحدثين، وتقييم الأوراق العلمية، ما أسهم في تنظيم منتدى يليق بسمعة هذا الحدث. وقبل أن نبدأ برنامجنا اليوم ندعوكم لمشاهدة فيديو قصير يستعرض رؤية عمان 2040.
معا تتقد أحلامنا، ننظر لوجهة واحدة، معا آمنا أينما كنا، نشق الصخر لبلوغ الغاية، فقط لأننا آمنا. نحن والأرض نشبه بعضنا، هي سرنا ونحن إنسانها الوفي. معا ندرك عظم المسؤولية فنتآزر. معا وبقلب جسور نقبل التحدي. معا سنحكي القصة من المزيج إلى العبق. معا يمكننا، فسعينا لتمكين من حولنا. معا أيقنا من هنا يلمع المستقبل.
النجاح هذه الرؤية مسؤوليتنا جميعا أبناء هذا الوطن العزيز دون استثناء، كل في موقعه وفي حدود إمكاناته ومسؤولياته.
معا نتقدم.
والآن ندعو المهندس عبد الله بن سليمان الوهيبي رئيس شعبة الكهرباء والطاقة بمعهد مهندسي الكهرباء والإلكترونيات IEEE PES إلى المنصة لإلقاء كلمته الترحيبية.
بسم الله الرحمن الرحيم، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. معالي الدكتور خميس بن سيف الجابري رئيس وحدة متابعة تنفيذ رؤية عمان 2040 راعي حفلنا الكريم. السلام عليكم أصحاب السمو، أصحاب السعادة، الضيوف الكرام. السلام عليكم ورحمة الله تعالى وبركاته. أصالة عن نفسي ونيابة عن معهد مهندسي الكهرباء والإلكترونيات في سلطنة عمان IEEE، يشرفني أن أرحب بكم جميعا في حفل افتتاح النسخة الثالثة من مؤتمر عمان للكهرباء والطاقة. معالي الدكتور، إن جهودكم الدؤوبة في دفع رؤية عمان 2040 تمثل مصدر إلهام لنا جميعا، ونحن ممتنون لحضوركم وتشريفكم لنا اليوم. شكرا جزيلا لكم. لضيوفنا الذين ينضمون إلينا لأول مرة، أود أن أقدم لكم نبذة عن معهد مهندسي الكهرباء والإلكترونيات IEEE. IEEE هي منصة فنية عالمية تطوعية تضم أكثر من 40,000 متخصص من مهندسين وأكاديميين وخبراء في قطاع الكهرباء والإلكترونيات والطاقة من مختلف أنحاء العالم، جميعهم يعملون لتحقيق هدف مشترك وهو تطوير التكنولوجيا لخدمة الإنسانية. ويعد المعهد أحد المصادر الرائدة للمعلومات العلمية والهندسية في هذا المجال. يمثل مؤتمر عمان للكهرباء والطاقة منصة محورية للابتكار والإلهام وتبادل الخبرات. يتماشى موضوع المؤتمر لهذا العام بشكل مثالي مع التحديات والفرص التي تواجه كافة القطاعات، حيث تلتقي الاستدامة مع التقدم التكنولوجي في نقطة تحول هامة. المناقشات التي سنخوضها ستسهم في تشكيل مستقبل قطاع الكهرباء والطاقة في السلطنة. ومن خلال فعاليات هذا المؤتمر نهدف إلى تعزيز التعاون الفني وتبادل المعرفة والخبرات وتطوير المهارات الفنية في هذا القطاع الهام والمحوري. وخلال اليومين المقبلين سنستعرض معا مجموعة من الموضوعات الهامة التي تشكل مستقبل هذا القطاع، بما في ذلك سوق الطاقة الكهربائية، أنظمة الطاقة وحلول الشبكات الكهربائية، أنظمة التوزيع، إدارة الأصول، إدارة الطاقة وكفاءتها، الطاقات المتجددة، وحلول تخزين الطاقة. إلى جانب ذلك سنناقش تأثير الرقمنة والأتمتة على إدارة أنظمة الطاقة مما يجعلها أكثر ذكاء ومرونة وكفاءة. أدعوكم جميعا إلى المشاركة الفعالة، سواء من خلال طرح الأسئلة والمناقشة وتبادل التجارب والخبرات فيما بينكم وفي مختلف القطاعات. معا سنعمل على دعم رؤية عمان 2040 وتعزيز مستقبل مستدام للطاقة في سلطنة عمان. وفي الختام أتوجه بجزيل الشكر والتقدير لمعاليكم على رعاية حفلنا اليوم، كما أتقدم بالشكر إلى مجموعة نماء على استضافة هذا الحدث السنوي، وهيئة تنظيم الخدمات العامة وشركة تنمية نفط عمان، وجميع الرعاة والمشاركين على دعمهم الكبير الذي جعل هذا المؤتمر ممكنا اليوم، ولله الحمد. ولا يفوتني أن أوجه شكرا خاصا لأعضاء اللجنة الفنية وكل من عمل خلف الكواليس لضمان نجاح هذا المؤتمر. وأخيرا شكرا لكم جميعا ضيوفنا الكرام على حضوركم وتشريفكم لنا اليوم. نتمنى للجميع التوفيق والنجاح في فعاليات مؤتمر عمان للكهرباء والطاقة، والسلام عليكم ورحمة الله تعالى وبركاته.
نغرس في الوطن بذرة تمثل امتدادا لعراقته، نرويها من ضمائرنا فتكبر، نرويها من أصالتنا فتكبر، من حبنا ثم من معارفنا تكبر وتكبر، نرعاها بمزيد من العناية والعطاء فتنمو لتغدو شجرة عملاقة قادرة على العطاء والبذل. العطاء في بلادي ليس بالأمر الغريب، لأننا بالطبع نستمد عظمتنا منه، من الشجرة العملاقة التي نحن ثمارها جميعا، في كل شبر منها تسكننا ونسكنها وطننا عمان. من البذور الصغيرة وحتى الثمار المجيدة، أحدثكم اليوم عن رحلة تحاكي عناية العمانيين ببعضهم البعض لتأسيس حياة جميلة تتوارثها الأجيال. ننمو مع كل مسار عمل، نطور قدراتنا المتنوعة، نعزز خدماتنا المقدمة، نبني على إنجازاتنا السابقة، نرتقي فوق حدود الإبداع، نجتمع معا لنكمل رحلة النماء.
والآن ندعو الفاضل أحمد بن عامر المحرزي الرئيس التنفيذي لمجموعة نماء لإلقاء الكلمة الافتتاحية، فليتفضل مشكوراً.
معالي الدكتور خميس بن سيف الجابري الموقر، رئيس وحدة متابعة تنفيذ رؤية عمان 2040 راعي المؤتمر، أصحاب السعادة المكرمون، رؤساء وأعضاء مجالس الإدارات التنفيذية، الضيوف الكرام، السلام عليكم ورحمة الله وبركاته. نيابة عن مجموعة نماء يشرفني أن أرحب بكم جميعا في حفل افتتاح النسخة الثالثة من مؤتمر عمان للكهرباء والطاقة الذي نستضيفه للعام الثالث على التوالي. لقد كانت وما زالت مجموعة نماء جزء لا يتجزأ من مسيرة الطاقة في عمان على مدى عقود، حيث شهدنا عن قرب كيف تؤثر الطاقة على حياة الأفراد وكيف تسهم في تحريك عجلة الاقتصاد وتعزيز التقدم. على الرغم من التحول الملحوظ نحو تنويع مصادر الطاقة والتركيز على تعزيز الاعتماد على مصادر الطاقة المتجددة بفضل التزام الحكومة الراسخ والسياسات الشاملة، ألا أنه ما زالت هناك العديد من التحديات التي يواجهها قطاع الطاقة، تشمل تغير المناخ وزيادة الطلب على الطاقة والحاجة إلى أنظمة أكثر استقراراً ومرونة. وهذه ليست مجرد تحديات تقنية أو فنية فحسب، بل هي تحديات تتعلق بكيفية مواصلة اهتمامنا بكوكبنا وضمان استدامته للأجيال القادمة. ولذلك فإن اجتماعنا اليوم لمناقشة هذه القضايا معا يعكس أهمية التعاون في إيجاد حلول مبتكرة وفعالة. إن استضافتنا لهذا المؤتمر يجسد التزامنا الراسخ بدعم تحول الطاقة في السلطنة والمساهمة الفاعلة في تحقيق رؤية عمان 2040، حيث يمثل هذا الحدث اليوم منصة تجمع الخبراء من مختلف أنحاء العالم لمناقشة التحديات التي نواجهها واستكشاف الحلول وتبادل الأفكار التي تسهم في تسريع وتيرة التحول نحو مستقبل مستدام للطاقة في عمان. حضورنا الكريم، نسأل الله تعالى أن يحقق لهذا المؤتمر والمعرض المصاحب أهدافه لدعم الجهود التنموية في هذا الوطن العزيز تحت ظل القيادة الحكيمة لحضرة صاحب الجلالة السلطان هيثم بن طارق المعظم حفظه الله ورعاه. وفي الختام نتقدم بجزيل الشكر والتقدير إلى معالي الدكتور خميس بن سيف الجابري الموقر رئيس وحدة متابعة تنفيذ رؤية عمان 2040 على رعايته الكريمة لحفل افتتاح هذه الدورة من المؤتمر، وإلى اللجنة المنظمة وهيئة تنظيم الخدمات العامة على جهودهم المبذولة لإنجاح أعمال المؤتمر. كما أود أن أغتنم الفرصة لأعرب عن شكرنا لمعهد مهندسي الكهرباء والإلكترونيات وشركة رايا للخدمات على جهودهم في جعل هذا الحدث ممكنا، والشكر موصول إلى جميع الشركاء الداعمين للمؤتمر ولكم جميعا حضورنا الكريم على تشريفنا اليوم، مع تمنياتنا بالتوفيق والنجاح لهذا المؤتمر. والسلام عليكم ورحمة الله وبركاته.
شكرا جزيلا لك. والآن ننتقل إلى العرض الرئيسي للمؤتمر، وندعو الدكتور هيثم أبو الرب المدير الإداري لمركز الشبكة الذكية وبروفيسور الهندسة الكهربائية والحاسوب في جامعة تكساس A&M في دولة قطر، وزميل معهد مهندسي الكهرباء والإلكترونيات IEEE لإلقاء عرض تقديمي بعنوان الطريق نحو مستقبل أنظف وأذكى للطاقة الكهربائية، فليتفضل مشكورا.
بسم الله الرحمن الرحيم. معالي الدكتور خميس بن سيف الجابري، أصحاب السعادة القائمين على المؤتمر، الحضور الكريم، السلام عليكم ورحمة الله وبركاته. Thank you very much for inviting me. I will speak and present this talk in English, and I appreciate inviting me, and this is an honor for me to be here in Oman. So let us proceed with the talk. So I will speak about the pathway to a cleaner and smarter electric energy future. So the outline will be introducing the topic, then the challenges on this pathway, and how we can turn those challenges into opportunities. Then we'll talk about the grid connected inverters, so putting lots of requirements and strict codes actually to enable the transformation to a cleaner energy. So then we'll speak about the renewable energy, how those can be really active grid players for our future grid. So this is our traditional grid that all of us know, and it has almost 130 years old, and it's based on synchronous generation. So speaking about the synchronous generator with the rotating masses, those contribute to the stability of our current grid. So under demand supply unbalance, generation load unbalance, the synchronous generators maintain synchronism and prevent the grid from blackouts and any other disturbances in energy supply. So the rotating masses contribute to kinetic energy, either to the grid or absorbed from the grid as a result of the frequency variation. This is what we have currently when the grid is still based on synchronous generation. And still worldwide, this is based on the synchronous generation. But we are moving toward more and more renewable energies. With the renewable energy now, so we have the power electronics converters. So those are grid connected. And power electronics converters, those act very fast. So they have low inertia, and they are prone to instability much, much faster than the synchronous generation. So those are now required to operate in the same way to have a functionality as synchronous generators with very tough requirements. Are we moving to this dominated, power electronics dominated grid or renewable energy dominated grid? The data shows that, yes, this is the future. And worldwide, the increase in adopting renewable energies is more than 20% yearly increment. And we see the installation, actually, the infrastructure of the new generation plants is more toward renewable energies. The green is renewable energies, so heading toward renewable energies worldwide. So this is the case. But now, while moving to this renewable energy based power plant, which is power electronics based power plant, brings lots of challenges. And with this inertia, because synchronous generators, they have large inertia and contributes to the stability of the grid, the power electronics, they don't have this inertia. So what we have here, we have a grid that is based on many distributed generations. So we are moving the functionality of the bulk power system to the grid edge with a huge number of generations, and those working at different levels of this inertia. So we need to approach the dominated renewable energy grid while not jeopardizing the stability of our grid. So it should operate at different levels of this so-called inertia. One of the big challenges is the generation variability. So this is an example of a wind park in the US. While the green is the wind generation and the blue is the load variation. And those are negatively correlated. And this is the case. So the generation, the renewable energy generation is stochastic in nature, which is a big challenge. Storing this amount of energy for the whole grid is too expensive. It is not a viable solution at this stage. Maybe the future will change, but currently no. So here, moving toward the so-called smart grid, in which we change the paradigm. So our grid would rely on having the load follow the generation, not as we have here, the generation is following the load. So wherever we connect more load, we burn more fuel and generate more energy. But here, so the smart grid and demand response should be a major part in our future grid. One of the challenges and opportunities is the electric vehicles now. So the electric vehicles is being adopted worldwide in much faster than envisioned. And this will be the future. It is coming very fast. And those are more associated with the charging stations. And everyone would like to have fast charging station and ultra-fast charging station and faster. But this is a huge burden on the grid again. So it's not only the renewable energy, but now we are connecting again something that was not envisioned earlier. This is an example about the operation of those charging stations. If we see here, the fast charging, the DC charging station, the fast charging station can draw up to 500 or 1,000 amperes at the beginning. And those all electric vehicles, they have charging modes, and they start with the so-called current, constant current charging mode, and then they move to the constant voltage mode, and then constant current charging mode. And most of the time is under the constant current charging mode, which is the highest current drawn. And you speak about many of those vehicles. This is very huge challenge to the grid. But those are actually the charging stations, they can support the grid. So looking at moving those challenges into the so-called opportunities. So here, what is the future, and having the support from those charging stations into supporting the grid with the renewable energies. Renewable energies should be a major part, actually, a major part in the grid, in supporting the grid, so PV system, and you have a multi-terminal DC charging station, fast charging station, and this is envisioned also to support the grid. Mainly should rely on the renewable energies, have on storage, and utilizing with the demand response also the electric vehicle batteries, even the need to support the grid. So a lot of now interest in this, while having the charging station perform many of the functionalities and services to the grid. So we do such kind of research related to the fast charging stations to support the grid. And this is an example when a charging station is connected to a weak grid, and when you increase the load in the weak grid, the voltage drops, then the charging station can inject reactive power at this instant, the first EV, the second, the third, to restore this voltage. So here performing support to the grid. So different examples, and this is very important when we incorporate the PV system within the charging station. So initially, you have this amount of power drawn from the grid, and then once the PV starts increasing, the amount of power taken from the grid decreases. And then starting, the extra energy can be injected to the grid. And if the need of the grid, if there is an instant in which the grid needs more power, so this would be at the cost of charging the electric vehicles, which means that those would be a very big support to the grid. So now those inverters, they have very, very tough requirements. And those tough requirements in operating those inverters or renewable energy systems in different modes. And those modes, so-called grid following and the grid forming. Grid following or grid feeding, and most of the DGs worldwide currently are working in the grid following. What's the grid following? Capturing the maximum amount of power, and this is the interest, and injecting this to the grid. When this increases, this would jeopardize the stability of the system. So moving for more and more renewable energy, this cannot be the case. So here becomes the so-called grid forming. So those DGs should build the grid. So more and more requirements for that, which will increase sharply, highly would increase the cost of renewable energy systems. And many, many of the requirements, such as operating at the so-called specific curtailment. So to have spinning reserves and non-spinning reserves. So all this would increase the cost of renewable energies. But the power electronics here with the control are required to operate at this mode to ensure the stability of our grid. But fortunately, all this is doable. So you speak about here synthetic inertia, about synthetic damping, about supporting voltage support, about frequency support, about different types of support for the grid. So comparing the synchronous generator with the power electronics, DG based on the power electronics one is very, very fast and with low inertia. But all this can be improved, and always you can modify the control and then ensure proper operation that could be even better than what is based on the synchronous generator. So the whole fast charging station with many terminals can even make a grid forming and can support critical infrastructure in case of any lack of supply from the grid. So we are doing such kind of research, and very successful in terms of operating the EV charging system in the modes of of a grid feeding and then moving to grid supporting and grid forming, even if there is a lack of supply from the power grid. So renewable energies are now under very tough requirements, strict codes that increase the cost of renewable energies, but those would enhance injecting more and more and moving faster and faster to the renewable energies. And here we speak about intelligent unit, intelligent device, and intelligent system, which make the system stable in all the direction. And finally, would have the new generation, the renewable energy, perform much better than the our traditional grid. With that, I conclude that yes, the future is moving toward renewable energy based, more expensive, but affordable to have a stable power grid. So this is the pathway to our future grid. I would like to thank many of my colleagues, researchers, while doing very advanced research. And thank you, shukran, barakallah fikum.
Thank you for your insightful presentation, Dr. Al-Rab. وفي الختام نتشرف بدعوة معالي الدكتور خميس بن سيف الجابري رئيس وحدة متابعة تنفيذ رؤية عمان 2040 راعي الحفل، والمهندس أحمد بن حمد الصبحي رئيس مجلس إدارة مجموعة نماء، والفاضل أحمد بن عامر المحرزي الرئيس التنفيذي لمجموعة نماء، والدكتور أحمد المعشري رئيس معهد مهندسي الكهرباء والإلكترونيات بسلطنة عمان، لتقديم الهدايا التذكارية لشركائنا الذين ساهموا في نجاح هذا الحدث. نود أن نكرم هيئة تنظيم الخدمات العامة. شركة تنمية نفط عمان. شركة فولت أمب إنرجي. شركة هيتاتشي إنرجي. شركة سيمنز. شركة فينيكس باور. شركة مرافق. شركة سوجكس. شركة زواوي باورتاك. شركة حمد للخدمات الهندسية. شركة IEEE. شركة يونيكورن. شركة عمان كيبلز. بالنيابة عن معهد مهندسي الكهرباء والإلكترونيات، يسرنا أن نقدم هدية تذكارية إلى متحدثنا الرئيسي الدكتور هيثم أبو الراب تقديراً لمشاركته القيمة، فليتفضل مشكوراً. كما نتشرف بتقديم هدية تذكارية لمجموعة نماء تقديراً لاستضافتها الكريمة لهذا الحدث. وفي الختام نتوجه بخالص الشكر والتقدير لمعالي الدكتور خميس بن سيف الجابري رئيس وحدة متابعة وتنفيذ رؤية عمان 2040 على رعايته الكريمة لهذا الحفل، ونتشرف بتقديم هدية تذكارية لمعاليه تعبيراً عن عميق امتناننا. بهذا نصل إلى ختام حفل الافتتاح، وندعوكم الآن لمرافقة راعي الحفل لافتتاح المعرض المصاحب. حضورنا الكريم، نذكركم بأننا سنعود إلى هذه القاعة لاستئناف جلسات المؤتمر بعد نصف ساعة. شكراً لكم جميعاً على حضوركم ومشاركتكم، والسلام عليكم ورحمة الله وبركاته. Thank you all for coming, and please be seated because we're about to start our first session for the day. So our first session of the day is called Power Market Updates and is moderated by Mohammed Al-Lawati. Please come to the stage.
Assalamu alaikum and good morning everyone. Thank you for joining us today at the IEEE PowerTalks in our beautiful city of Muscat. My name is Mohammed Al-Lawati. I'm heading the renewable energy section within Petroleum Development of Oman. I would like first to thank all of the organizers, sponsors, and partners of IEEE PowerTalks to provide me this opportunity to take you through, inshallah, to the first theme of the conference on power market updates. Our goal today is to explore on Oman energy transition strategies, regulatory updates on the electricity sector and the renewable energy plans in Oman. Also, we will bring some of the international expertise in the subject. We'll bring some exciting case studies from Germany. We'll bring some experience from Poland as well. So I think we have some very exciting subjects. I'm very excited today as well to have with us an elite expertise panelist with us today. We will basically hear from each speaker, and after all of them being presenting their presentations, we'll have a panel discussion and followed by opening the floor for questions from the audience. We'll start, inshallah, with the first session on Oman energy transition strategies, presented by Mariam Al-Hashmi, Director of Electricity and Energy Efficiency Policies and Strategies at the Ministry of Energy and Minerals. Mariam is a policy and strategies specialist with over 15 years of experience in policies and strategies development. Over her working experience in the government entities, she had participated and led several policies and strategies projects relevant to the overall energy sector and electricity and water sector. Before her current role, she held different positions at the formal Public Authority for Electricity and Water and the Ministry of Economy. Please welcome Mariam to the stage.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. It's a great pleasure for me to present the energy transition strategies and policies today. But before speaking in details about the energy transition policy, allow me first to confirm one thing. Energy transition is a journey. It's not one-time effort. And there's a lot of effort done before the Ministry of Energy and Minerals energy transition policy projects. And it's also a collaborative effort by the different sectors in the country. And it's the responsibility for everyone in this country. Speaking about the journey, as I just said, it started long back before the Ministry of Energy study, Energy Transition Policy study. It started in 2021 by the Hydrogen Economy Feasibility Study and by the establishment of hydrogen alliances, HyFly, in 2021 as well. In 2022, the Royal Directive for Hydrogen Sector came, which directed the Ministry of Energy and Minerals to set the required strategies, policies, and regulation to enable the hydrogen sector, and also to establish the General Directorate of Renewable Energy and Hydrogen in the Ministry of Energy, and to establish hydrogen company. And also, it's direct the ministry to allocate the lands for green hydrogen and renewable energy. As a response to these directives, in June 2022, the Ministry of Energy and Minerals has floated two tenders for the development of energy strategies and policies and the development of legal framework to enable the hydrogen sector. And also at the same time, there was the incorporation of hydrogen. The two study has been completed in Q1 2023. And at the same time, there was, during the study period, there was the announcement of net zero target by 2050 in October 2022. And after the completion of the study, there are other milestones, including the announcement of the winning bidders for round 1 hydrogen block auctions in Q2 2023, followed by the announcement of the second auctions, winning bidders for the second auctions in Q2 2024. Speaking about the energy, before speaking also about the energy transition, I would like to shed the light on why we need energy transition. As you all might know, the Vision 2040 has set very ambitious target for the GDP growth, which is 5% per annum in per annum. This GDP growth is associated by a big growth in the energy demand. To meet this 5% growth, or even less, more softer targets, which is about 3 to 4%, the energy demand is expected to grow from the 350 terawatt in 2021 to reach about 800 to 1,100 terawatt hour in 2050, driven mainly by the hydrogen sectors and the energy intensive industries. But the good news is that Oman has extensive potential to develop solar and wind energy, which is capable to meet the current demand for 2050 and exceed it by above 5 times, using the land allocated for renewable energy and hydrogens. The vision for energy transition is Oman shall fulfill net zero by 2050 while ensuring energy security, competitiveness, growth, a low carbon economy, and value to society. This vision is based on 5 main building blocks, and 6 main building blocks actually. It's the energy efficiency, renewable energy, hydrogen economy, electrification, fossil fuel, including CCUS, and the smart grid to enable reliable and efficient integration of renewable energy into the grid. It is also driven by 5 guiding principles. The first one is to ensure energy security, which aims to enable the country to respond to any sudden growth in the demand and make timely investment with the limitation of the requirement to respond to the economic development demand and with the limitation of the environmental requirements. It also aims to decarbonize orderly, which focus mainly on decarbonizing the sectors with low abatement cost and moving gradually to harder to abate sectors. And it also aims to develop the transition enabling capabilities, which is the fundamental requirement for energy transition, is to build the local skills and create high-value jobs for energy transition. The fourth one is to grow low-carbon economy, using producing clean hydrogen, and especially the green hydrogen can create a new venue for Oman to export energy as in form of hydrogen or hydrogen derivatives. The energy also can be exported in form of electrons, renewable energy through the interconnections with the neighboring countries, or even using the submarine cables to export energies. Also, utilizing the renewable energy and green hydrogen will free up some of the natural gas that would have been used locally for the local industries and for power production, and that freed up gas could be used for export at the competitive export rate of gas. To achieve this, guiding principles and the target, Oman has set 5 energy transition targets. The first one focused on the sectorial energy efficiency targets, and the second one focused on the green power system targets, which I will speak about these two in details in this present today, as this is relevant to the power sector. And we have set also a target in the local hydrogen economy and the zero emission vehicles, and the final one is the carbon capture targets. Speaking about the targets, I will speak about the hydrogen economy targets. So this target has been previously announced, and the target is to produce 800 megaton per annum by 2050 and 3.5 megaton per annum by 2040. And part of this production will be allocated for the local consumptions to build the hydrogen economy locally. And by 2050, this about at least 1.7 megaton per annum will be used locally. We have also set the target for the zero emission vehicles, and for the passenger zero emission vehicles, we set a target to reach 100% new sold zero emission vehicles by 2050, and again 100% for the commercial zero emission vehicles by 2050. This target, I need to highlight, this target is not relevant to the fleet in the roads. It's for the new sold cars in the country. For the CCUS, to deal with the residual emission in hard-to-abate sectors, we will still have emission that cannot be replaced in the industry, that cannot be decarbonized by using renewable energy and hydrogen. And this emission will be captured through the carbon capture, and that could be either utilized or stored. Speaking about the energy efficiency targets, we have set the targets in the energy consumption to reach 6% megajoule per US dollar energy consumption target by 2050. The current number is 13.5 megajoule US dollar energy in the energy supply. And the target is to move gradually to 13 by 2030 and 9% by 2040. We have also, we tried to come up with a target that is not linked to the GDP. And after analyzing different indicators, the decision was to choose the score from the American Council for Energy Efficient Economy. And currently Oman is not registered in this organization. And our target is to reach 35 out of 100 points score in 2030 and to reach above 70 by 2050. Currently, there are 2 GCC countries registered in this non-profit organization, which is United Arab Emirates and Saudi Arabia. Speaking about the benefits of energy efficiency, it's as known, it will reduce the consumer bills by reducing the consumption of the energy in the houses and in the industry. It will also defer the investment in the grid investment, which will save the money for the country as the electricity sector is still subsidized, and it will also free up some natural gas by not consuming this gas for the power production. Moving to the targets in the renewable energy, 3 system archetypes has been analyzed by the team defining the energy transition strategies and policies. The first one is the flue system, which focus in using the natural gas as a base load and to meet the peak demand, and it's required to be associated with the carbon capture technology to meet the net zero. And the second system is the pink system, which uses the nuclear system for the base load demand. And the third one is a green system, which is based on renewable energy for the bulk and energy demand, and it will utilize the energy storage as batteries and pumped hydro to deal with the intermittent energy, renewable energy supply, and will also assume that the peak demand can be met promptly through using the hydrogen peakers, and also through the long-term pump hydro storage. The outcome of the analysis of the three systems shows that the green system, partially integrated with the hydrogen production facility, is the optimum for Oman, as it has the lowest levelized cost of energy. This assumes that around 12% of the hydrogen production will be integrated with the grid. That can be used as to leverage the excess power in the grid to be used for hydrogen production, and also to curtail the electrolyzer in case of the supply bottleneck in the grid. Sorry. Going back to the targets of renewable energy, the targets is, it was assumed in the Vision 2040 as 20% by 2030 and around between 35 to 39 in 2040. The new defined target by the Energy Transition Policy for Oman is 30% by 2030 of in-grid renewable energy consumption, and 70% by 2040 and 100% by 2050. And the driver of that is we need to achieve the net zero by 2050. So we have to have zero emission. This slide is only explain the three systems. To enable the achievement of this target, we need to regulate and educate people about the each sector. We need to incentivize, regulate, and educate people about the role of each person and sector in the energy transition journey. And for that, we have defined two sets of policies. The first one is the bold stride, which is immediate policy action that need to be implemented immediately. And the third one is a steady stride, which is a policy roadmap that need to be implemented in a continuous manner to ensure proper implementation of the targets and proper transition of the sector. Speaking about the immediate policies, the first one is to make government green and energy efficient, which is a holistic initiative for government entities to take the lead in energy transition and lead by example. And this will create the local market for energy transition, especially for the energy efficiency and for the small scale in renewable energy. It will also focus on transiting the transportation fleet in the government to be automated and using electric vehicles and maybe in the future hydrogen cars. The second one is to kickstart local green hydrogen economy, which aims to enable and accelerate local consumption of green hydrogen in different sectors. And the purpose of this policy is to advance technology and building the local know-how in the energy security and to attract investment. So that by that we will need to advance the small-scale hydrogen production before moving to the targeted large-scale production, just to prepare the market for the large-scale hydrogen production. And the third one, and the most important one for me, is to drive awareness, skills, and innovation, just to ensure the public acceptance of the transition and to ensure that everyone is playing his role in this journey. And it aims to drive the green decisions in the country and promote renewable energy and e-mobility among the public and the private sector. Also, making fund schemes available is a very important policy decision, which aim to monitor the available sectorial funding from the existing funding schemes, and also to identify the gaps if there is a gap and notify the responsible party or entity about creating those funds if there is a need. And finally, the fifth policy, immediate policy, is to set up government framework which will enable the chasing of the achievement of the targets and the implementation of the policy, and correct the action if there is any correction needed. The implementation of this bold stride has been assigned to different parties. For example, for making government green and energy efficient, it has been assigned to Oman Net Zero Center in collaboration with the Ministry of Energy and Minerals. And for creation of the green, local green hydrogen economy, it has been assigned to Integrated Gas Company as it's interrelated to the gas demands. And for driving awareness, it has been as skills and innovation, it was assigned to the Ministry of Higher Education. And for making funding scheme, it was, as it's only monitoring and identifying the gaps, it was also assigned to Oman Net Zero Center. And finally, to set up the government framework, it was assigned to Ministry of Energy and Minerals. With this, I've concluded my presentation. Thank you for your attention.
Thanks, Mariam, for this insightful presentation on Oman specific energy transition journey. Next, we would be delighted to bring forward the perspective of Oman regulatory update on the electricity sector, presented by Mahmoud Al-Habsi, Manager of Technical Regulation at the Authority for Public Services Regulation. Mahmoud has over 15 years of experience working in the Authority for Public Service Regulation. His role is mainly focusing in monitoring technical compliance of the licensed entities to the industry codes and standards, and reviewing and approving capital expenditure allowances within the regulatory frameworks. His role also involves conducting system failure investigations and conducting audits to ensure full compliance of the sector companies to health and safety. Please welcome Mahmoud on the stage.
Thank you for the introduction. Good morning, everyone. I'd like today to present some regulatory updates on electricity sector. In this presentation, I'm going to cover the following. First of all, I'm going to talk about an update on electricity market structure. That would include some system peak demands data in 2024. And after that, I'm going to speak about a regulatory study that has been undertaken by the authority, putting the possible grid implications due to the widespread of self-supply. And finally, I'm going to talk about the EV technical standard guidelines that has been issued by the authority. So this figure shows the electricity market structure consisting of generation, transmission, distribution, and supply, and one single procurer, which is the NAMA Power and Water Procurement Company. The first update in the structure is the restructure of the distribution and supply. In the past, there were 4 distribution and supply, namely Muscat, Majan, Mazoon, and Raiko, and now it's 1 distribution company and 1 supply company doing different businesses. So this mainly was to streamline the processes and the procedures, and also to ensure efficiency within the spend of the sector. The second update is related to the rural areas electricity company. In the past, it was vertically integrated company and has moved now to horizontal integration. The other business of rural areas electricity company has been moved to the other sector companies. For example, the transmission assets has been moved to the Oman Electricity Transmission Company, and the distribution aspects moved to both NAMA Electricity Distribution Company and NAMA Dhufar. This figure shows the system peak demand at different locations in 2024. So Msandam peak demand was 93 megawatts, which is around 8% more than 2023. The MIS system peak, which is the biggest system in Oman, reached 7.7 gigawatts, and that is around 5.5% more than 2023. And finally, Dhufar was 842 megawatts, having the huge increase, which is around 24% because of the connecting of large industrial customers. The dotted lines is the approved CapEx by the authority to interconnect the north with the south for phase number 2. That is expected to be in place by 2027. And this is in line with the directions of Vision 2040 directions to decarbonize the net zero and reach the net zero targets and reduce the electricity prices and ensure security of supply. So for each of them, there was a review of generation mix by NAMA Power and Water Procurement Company, and this was in coordination with the authority. And there was a review of the system cost reflectiveness that included bulk supply tariff and transmission use of system charges. And the authority is currently working on the review of distribution use of system charges to have more reflectivity on the cost. To ensure that decarbonization are moving towards net zero, which will include intermittency of power, there was also a review of system balancing requirements, which has been undertaken by Oman Electricity Transmission Company in coordination with the authority, and have produced a roadmap on that. So working in the authority makes us think about that there is a need. Is there a need for a market structure and regulation? And the answer was yes. So the authority is currently working with MEM on an ongoing market review study. The objective is mainly to design and capture overall changes within the sector and make it more competitive. So any technological changes within the sector, how we can put it in the sector within regulatory frameworks. The scope includes a full review and benchmark with other jurisdictions and conducting gap analysis, and review also planning processes, which includes generation and generation security standard and network security standards. So before going to the study about the self-supply, just I'm providing here a definition from the sector law for the self-supply. So, or auto-generator. Auto-generator is a person who generates electricity for the purpose of self-supply. And there are several types of self-supply scenarios. So there are customers who are off-grid and doesn't impact the grid at all. There are customers who are connected to the grid and therefore would impact the grid. And for the non-auto generation, there are some customers who are willing to wheel the power from one location to another. So a large industrial customers came to the authority requesting for exemptions. According to the law, if they are exceeding 25 megawatts, they have to get an exemption from the authority. Or if it's less than 25 megawatts, but they want to connect to the grid, they have to get an exemption from the authority. So large customers came, their drivers was to decarbonize in line with the Vision 2040 and to produce green products and to avoid the cost during the peak. So the question that came in mind, what are the technical and economic consequences of approving that self-supply request from the customers? So the potential consequences that has been studied by the authority is the increase in the government subsidy because of building new power plants, and this would increase the cost and tariff for the customers who don't use self-supply. This might increase the operational complexities to the system operator and may impact the recovery plans from the single procurer, and it may increase the curtailment within the sector. So I'm providing here some hypothetical scenarios for the context of self-supply. For this specific scenario, a grid-connected self-supply customer not importing or exporting from the grid. So the current costing structure of BST doesn't have a breakdown. So zooming out on the BST components, there are non-avoidable costs and avoidable costs. So when the self-supply customer is not importing or exporting to the grid, it's actually having a fixed generation cost and ancillary service cost because of the booking of that capacities by the single procurer and the also transmission or grid if it's distribution or transmission. So another scenario is when a customer wants to wheel the power from one location to another. So in this instance, the avoidable cost would also be incurred, which is the average losses to the system. I'm including also here the distribution use of system charge for this scenario if the customer is connected to the distribution system. So what would be the system implications? So I'm listing here what is the requirement in the grid code for the ancillary services. So there is frequency control, reactive power and voltage control, and black start capabilities. So with the increase of intermittency and PV generation or renewables within the system, there will be a need to revisit these ancillary services to have more faster, as has been mentioned by Dr. Rabb today. With regard to the system capacity planning, there will be several reinforcements within the network. The transmission company will go and reinforce the network for the capacities that need to be connected, and also the generation need to be booked or procured by the single buyer. So this will incur some system capacity planning and maybe over duplication on procuring the generation capacities. So let's have an example about a typical day in 2026 off-peak season where the demand is 3,500 megawatt. Let's say that this is unconstrained schedule. So the generation from, let's say, the solar, which comes from the power procurer and the self-supplier is 2,700 megawatts, which will squeeze the thermal generation to 800 megawatts. But when the curve starts to decay at 17 hours, the complexity will increase to the dispatcher, where he has to ramp a lot of generation within a very short period. If the control center decided no, the constraint schedule would require that we have a minimum demand, minimum generation in place, this will require a curtailment of the power. So who will pay that curtailment of power? Because that curtailment would have a cost. So this needs to be decided. So there are some options to mitigate curtailment. One of them is to increase demand, asking customers, industrial customers, to switch on their loads. And another one is to distribute energy storage around the system in Oman. And we can export that extra capacities within the GCCIA, or to have set a cap of renewable energy penetration for both the power procurer and self-supplier. So just to give a recommendation of the self-supply study that has been conducted by the authority, one of them was to develop an auto-generation policy, which has been now being in consultation by MEM. And in that policy, an annual energy cap would be need to be established between the stakeholders. Now I'm going to provide regulatory update number 2, which regards to the technical requirements guidelines. The content of the guideline is shown in this figure. The scope is mainly for small vehicles. It doesn't contain the wireless charging or bidirectional charging or EV to grid charging. And it has some local and international standards within it and modes of operation and the connection processes that has been approved by the authority. So this picture shows the spectrum of charging modes So mode 1 is prohibited in Oman and in other jurisdictions, and this is because of plugging the vehicle directly to the socket, which will cause risk of overheating and providing a safety concern. Mode 2, 3, 4 can be implemented, but with mode 2, there is a constraint, sorry. There is a constraint of having an in-control cable to protect the car and the socket, but this is incidental because, again, the sockets here in Oman are 13 amps and may 13 to 15 amps and may cause overheating. So mode 3 and mode 4 are the preferred modes of operation, where mode 3 have a dedicated vehicle to grid and a dedicated power socket. And mode 4 is the DC charging, which is the fastest charging. This is the approved connection process for the private customers according to the regulation 15 to 23. The owner has to connect the EV charging station by an approved contractor, and this has to be approved by the distribution company. So after submitting the application, the NEDC will review it, approve it, and then test it, and then it will go live. This is the public connection process. This is a little bit different. It's almost the same, but NEDC has to provide a cost estimate and connection point. So if that connection point requires any reinforcement in the network, they have to reinforce first the network and then provide the connection point to the applicant. I'm listing here some EV publications with some barcodes for reference. Thank you for your attention.
Thanks, Engineer Mahmoud, for shedding light on the regulatory update on the electricity sector, including giving us some perspective on the regulation of the electrical vehicles as well. Next, we'll move to NEMA Power and Water Procurement with Dr. Hilal Al-Nasri to present us on the renewable energy in Oman in terms of their potential and plan. Dr. Hilal Al-Nasri is the Planning and Economics Manager at NEMA Power and Water Procurement Company. In this role, which he has held since 2011, he's responsible for the generation capacity planning and the demand forecast within the electricity sector in Oman. Prior to that, he served at Oman Electricity Transmission Company in several roles as planning leader and also as a load dispatch center manager. His main responsibility is to ensure sufficient electricity capacities at an economic purchase basis to meet the growing demands in the Sultanate of Oman. This includes exploring the most optimum generation mix and exploring the latest technology development which will support the ongoing national decarbonization and sustainability visions. Please welcome Dr. Hilal to the stage.
Okay, thank you, Muhammad, and thank you for the organizing team. Always happy to be here and meet these expert people. My talk, I will limit it to the renewable energy plan that's done by OPWP or PWP, NEMA Power Water. It used to be called Oman Power and Water. Now it is NEMA Power and Water Company, and thanks to Mahmoud and Mariam, they covered a lot of long-term plans for the government. Renewable energy plan, let me see. Yeah, okay. So the outline of my presentation, mainly I will give a background of NEMA Power and Water Procurement Company, what we are doing. And also I will give what is our strategy, and I will limit my talk till 2030. Mariam and Mahmoud, they talk a lot about 2050 initiatives. Thank you. But I will limit my talks to 2030. Of course, I will shed a little bit about the challenges. Dr. Abu Rob already mentioned a lot of challenges, but at least we will mention whatever we think they are the key challenges of integrating renewables to the grid. And I'll shed a little bit about the other initiatives in terms of energy efficiencies and the other initiatives from the government. So, Nama Power and Water Company is a regulated entity company established in 2005. And its responsible is to sell power to the distribution companies and give it to the customers via bulk supply tariff. Its annual turnover around 900 million Riyal Omani. It's a very capital intense company. We have currently contracted capacity of about 9.7 gigawatt of installed capacity, mostly thermal working via gas, and there are 13 plants spread all over the country. We are also having around 1.3 million cubic meter per day of desalination water from 10 plants, and mainly they are RO plants. And there are some under construction projects, mainly solar. We have 2 main projects in Manah of a total 1,000 megawatt solar PV plants. Another 3, actually one already recently commissioned and established the COD. So what is remaining is 500,000 cubic meter per day under constructions, one in Muscat and Gobra and the other in Korea. So the supply areas, we have 3 main supply areas, actually 4 main supply areas. One of them is the main interconnected system, which is here in the north of Oman. And we have a Duqm, we have Dhufar and Musandam. Recently, we connected a Duqm with the help of OETC. They did it via Rabbit 1. It's a 400 kV link connecting MIS to the Duqm. So Duqm now it is part of the main interconnected system demand. That serves a lot in terms of saving a lot of diesel consumptions, and we minimize the total system cost. We will push further. OETC, they are already in progress to connect Duqm further to Salalah and via Rabat 2, and it is expected to be by 2027 in operation. Inline the link PDO, it's a well-known oil industry company. It has 4 connections nearly, and that will strengthen the whole system and will open up a lot of horizon for us to integrate more of renewables that I will show you later, where actually especially the wind concentrating in our country. Musandam, it's an islanded area which is also served by a gas power plant there. This is like a visionary for the ones who don't know where are the locations of our power plants and the RO plants. It is spread over the country, as I said, from the north to the south, and the renewable which are in the middle, mostly solar and wind. So what is our strategy? We are following the 2040 vision at the moment, and the 2040 vision target is 30% of generation to be from renewable by 2030, and between 35 to 39% by 2040. This is at the moment the vision of 2040. Of course, we are following the economic purchase, and if we see that we are getting more economics and competitive price for renewables, we can go more than 39% by 2040, and that's what we are thinking of, around 70% by 2040. Of course, the key objectives of this target is to release the gas, okay, and also to stimulate this economical growth. As Mahmoud and the other colleagues said, it's a lot of bulk customers nowadays coming to Oman, and they are also demanding on gas, and we try to find out the different options to generate our local generation. Now, what is the solar potential? Oman from north to south, it is either red or orange. It is sunny all the time. And we started actually, as per the statistics, the range between 2,000 to 2,500 kilowatt hour per meter square. More than 2 days per year, we have sunny shining, or shining sun, actually. The cost is very competitive. We start measurements in the middle of Oman. Measurement campaigns, actually we finished it. We have already recorded data in Manah 1 and Manah 2, which is already under constructions. We built the first large PV project in Ibri of 500 megawatt. It's already in operation. It is the first utility big-scale PV plant without storage. Under construction, we have the 1,000 megawatt, which is also under construction in Manah 1 and Manah 2. More projects are in the pipeline. I will show them in the list later. The wind as well, but the wind is very intermittent, first of all, and it is limited to very concise area of Oman, which is the central area between Duqm and Salalah. We start several campaigns. We finished it, few campaigns of data measurements. The wind, unfortunately, it needs that for the bidders and for the developers because of the intermittencies of wind. So we measured in several locations. In MIS in Ja'lan, we have in Duqm Ras Madraka, we have in Harwil, and we have in Sadah. In several locations, we are measuring the wind. There is one wind at the moment, it is running in Harwil 1, 50 megawatt, which was running since the beginning. Recently, we announced that there is a competitive, and we are about to early develop several locations. Ja'lan, about 100 megawatt in MIS. Duqm, about 200 megawatt. Mahut, about 300 megawatt. Harwil, about 100 megawatt, and in Sadah, and more of wind. The good thing of Oman, we can balance between solar and wind, so to compromise and help the system operation, as Mahmoud presented that figure of fast drop of solar in the night, it can be covered by the wind a little bit. Because the wind, it is available in the day and the night, so we will minimize that constraints of operation. Energy storage potential, we studied these options, and among several hundreds of technologies, we shortlisted recently 5 electrical energy storage technologies that we can see they are, in terms of the applications, we need it at the moment, and the maturity, the cost, and the weather conditions. Not all storages can sustain in our high temperature here, and also the maturity and the cost. And these 5 are the pump hydro storage, but pump hydro storage, it is a very well-known, matured technology. However, we need it if we need the storage for more than 6 hours. And this one needs comprehensive technical analysis and how much we need this storage. So if we need it for more than 6 hours, then pump hydro is very competitive. We have lithium ion, which is really the most optimum and economically useful for our system. So these are also the compressed air, the vanadium, and the hydrogen, of course. But most of them, they are less competitive compared to lithium ion. Recently, we tried to explore if we can build a small scale of battery within our we are developing a new 500 megawatt in Ibri again, and we try to explore a small PV lithium ion, storage or whatever type of technology within that, or co-located with the Ibri solar plant. For short horizon, up to 2030, we are targeting 30%, as I said, And the installed capacity energy projects can reach up to 6,000 megawatt by 2030. It is a mixture between solar and wind. What is the renewable energy technologies, the costs, the levelized cost? This is quoted from IEEE website. And we can see all the technologies are really decaying sharply, and we are having to, or at least we are targeting a very also competitive prices, levelized cost of less than 0.1 cents per kilowatt hour. Now, what are the challenges? The challenges, let me see that. There are three main challenges. The first one is the duck curve, what we call the duck curve, and that means it's very clear in the evening, where we are losing a lot of, the demand is low, high solar and wind, and in the night there is no solar. So that duck curve might end up running some of the must runs, and possibly there is some curtailments. Unless we introduce what we call the energy storage, or again, we sell it to our neighbors. We are connected actually to the GCIA, but unfortunately as well, they are developing heavily solars and they are coincide. They are at the same time where we have peak of solar, the other team members, they have also high solar generation. There is also another one which is about the capacity credit. We develop more renewables, but if 500 megawatt, we cannot rely 100% on 500 megawatt, because as I said in the night, it is not there. So we have to set a certain capacity credit to consider it in our capacity planning analysis. And this is a very comprehensive analysis and studies, and we came up with a capacity credit of about 20 to 25 for solar and about 30 to 35 for wind on average. That's the capacity credits for solar and wind at the moment, which is considered in our capacity plannings. What are the other initiatives? Already Mariam and the team, they mentioned, Mahmoud, Petroleum Development Oman, they are doing their own renewables, not only BWP, they are trying to develop more renewables, Amin, and recently 2 wind plants. OQ Alternatives, actually they are giving the responsibility to serve the big customers. And we have also Saham 1 and Saham 2, which is by the regulator. There's a new one called Energy Efficiency, very important, the ESCO one. The free zones, also they have their own initiatives, Shell of Oman, some of the schools. So everyone is thinking of renewables to minimize either their bills, or what we call bill shaving, or trying to also decarbonize and get clean, green products. That's all from my side. Thank you.
Thanks, Dr. Hilal, for showing us the perspectives, plans, and initiatives of renewable energy in Oman. Now we will turn to Professor Marek Jonsky. Maybe it's a difficult name to pronounce, who will take us through the cybersecurity strategies for renewable energy systems and their impact on power market stability. Professor Mark is the head of Industrial Electronics Division at Warsaw University of Technology at Poland. He's a prominent figure in electrical engineering with a focus on power electronics and renewable energy. And his current work focuses on intelligent power electronics converters for renewable energy and grid optimization. He has authored over 100 papers, co-authored patent, led multiple industry projects, and hold leadership roles in IEEE, including the chair of the Poland section. He is also an editor for several IEEE publications. Please welcome Dr. Marek to the stage.
thank you very much for the introduction and for inviting me. Thank you very much for a very nice presentation. It's almost nothing to tell more. However, before I will talk about the matter, I would like to say about the cyber secure energy, electrical energy storage with ancillary services, which I'm leading now in Poland at Warsaw University of Technology. So I think this is not, next slide is, okay, green, yes. So this is cyber security, yes, but my field mainly is power electronics. We are trying to understand now what we can do with increasing the cyber secure. So, but before I will go to this subject, this is just a way from Poland to Oman. This is not too far. And please visit us next year. This is a good opportunity to come to Poland because Eurocon will be organized next year. This is the main conference of IEEE Region 8. It means whole Europe, whole Africa and Middle East will be there. If you are interested in, I have also colport papers with me and I will distribute this with pleasure. Okay, so your government in Oman is amazing, I would say. You plan almost everything and our government is trying to do very similar. And it was a call New Technologies in the Field of Energy. It was quite well supported, but this is focused on prosumers and flexumers, okay? And this is in line with the strategy of European Union. What is the strategy of European Union? Of course, decarbonization, energy efficiency, energy security, and everything what is related to electrical energy. I'm from Warsaw University of Technology, so we are quite old university, first position in Poland according to the technical universities and third position in all universities in Poland. There are some numbers, I will just switch it to, because this is not important, but this slide is quite important because in European Union, all the best universities are trying to cooperate under the Enhance to teach people better. Yes, this is our future. Okay, so this is our main building with Maria Skłodowska-Curie. She was from Warsaw. She studied in France, but before she go to France, she was studying in unofficial university for ladies. In that time, in Poland, ladies couldn't study. This is the Wolfke. Wolfke is other example of our professor from our university. He invented hologram and a lot of interest in physics. And of course, Jan Czochralski, also professor from Warsaw University of Technology. Czochralski method is still used in semiconductor industry. Why semiconductor industry is important for us, for energy? I will try to explain you in a few minutes. So going to my faculty, because I'm from Faculty of Electrical Engineering. This is second biggest faculty at our university, and I think we have very good relation with industry. So the engineering without industry is nothing, yes? Industry is introduce our ideas to the life. So I'm from Industrial Electronics Division, and I'm the head of this division. What is, let's say, characteristic for us? We are focused on project-oriented teaching and project-oriented activity, thanks to my mentor, Marian Kazimierkowski. So going back to the main subject, cybersecurity strategies, yes? So how to implement cybersecurity or how it related with power electronics. Maybe this is not obvious. Let's take a look on the first point of my presentation. So telecommunication, and information processing. For me, was surprised this year. I was invited by a Polish Information Processing Society for their conference to explain the relation with the green energy. Is this more possibilities or dangers? Yes, you can imagine a blue screen in the power plant. It could be not fun. Okay, so what is power electronics? Power electronics is almost everywhere. Yes, this is some examples from the literature. You can see that all the modern power system, yes, is based on power electronics. Industry, pumps, hospitals, everywhere are power electronics. Even in your computers, mobile phones, smartphone, there are power electronics as well to supply the processors. There are several problems. For example, in measurement, because power electronics is good, but everybody hates it because we are producing a lot of interference, I would say. Because we are switching up and down, plus minus 1000 volts or plus minus 1000 amps, yes, in few microsecond or millisecond, depends on the problem. And now we are trying to understand how the digital twins can improve safety and stability or resilience of the grid, because here we are focused on power grid, a resilience is, yes, we should be flexible, okay? So since at least 2 years, every researcher tried to understand how the digital model can improve the quality of our research and decrease the cost. This is costly, yes, a little bit. You can see the real grid as a digital twin. It is quite costly. So how to transfer not only the energy, but also, sorry, not only the information, but also the energy, yes? IT, everybody understand. My youngest son understands this, yes? But when I'm talking about the energy conversion, they don't know what does it mean in the 4th year or primary school, yes? Energy converter, what is this? So AC-DC war, everybody remember from the beginning of the last century. Now this is the question if there is end of era of AC-DC war, and now we are going to AC and DC, let's say, symbiosis beginning. Thanks to this green box, yes? In this green box is AC-DC converter. Professor Aburup just talked about the possibilities that you can obtain, but please focus how many power electronics we have every day, and we must communicate them, quite fast communicate them. How fast? So let's imagine that those green box, inside of this green box we have a power electronics transistors, and those transistors switching the energy with microsecond, yes? And it's controlled by other transistors in a microchip, FPGA, and computers, and we are just connecting to voltage source and playing with the energy, yes? So, quite fun, but not, we cannot make errors, yes? And of course, electromobility. Why electromobility is now a hot topic? Because of semiconductors, of course. Wide bang-up semiconductors, yes? This is why we are now able to introduce this to the market, okay? Even in the mines, yes? And what about the smart grid and energy storages? Smart grid is not only a smart metering, yes? This is based on also, I will recall my mentor again, Professor Marian Kazimierkowski and Professor Tunia, a father of power electronics in Poland, used to say that thyristor was a father of power electronics, yes? In my opinion, now the silicon carbide and gallium nitride transistor is like a horses for the sustainable power electronics. We can do almost everything with those semiconductors, like a Pride of Poland horses, yes, from Poland, Arabic horses, yes? So this is the structure of this transistor, silicon carbide and gallium nitride. There is a lot of speech which is better. I can tell you both of them are excellent, yes? Of course, not only horses, farmers are focused on this. Proceeding of IEEE is focused on the modern energy transition. And you can see the example how we can impact the decarbonization by modern electrical power flow. You can see that almost all the energy processing depends on power electronics somewhere. Nobody knows this, but for example, we are not care about power supply in this building up to the moment where the power supply will be switched off. How to survive in this secret? This is the secret, yes? The energy storage, of course, this is short term because this is based on the electrical energy storage, but we can do a lot because it is flexible. Electrical energy is very, very flexible. And we can make some ancillary services based on this electrical energy. And this is not a secret that all of our computers, smartphones, refrigerators are using electrical energy, not hydrogen directly, yes? Hydrogen is very good. Of course, all of the stuff are very good. As you can see, for the wind farms or wave farms, we can use a HVDC system based on the electrical energy or hydrogen pipeline, yes? Going back to the app storage 2.0, this is just starting project, and we will finish this next year, the second stage. So the idea is not only to provide the energy storage, but we must be cyber secure. Nobody can switch off this without our knowledge. Nobody can enter inside without our knowledge. However, the main purpose is PQ quality. Yes, current control, voltage control, or energy control by the battery energy. Yes, and in this battery, this is not only the energy issue, there is also the 0101 subject, yes, just programming, yes. And of course, European Union and other countries is focused on that, not just from today, yes, from the beginning of computers. And this is the example how the problem is complicated, okay? That's why European Union introduced just this year NIS 2. What is this? This is the nightmare of the power system owner, yes? The power system owner will be responsible for the disaster if somebody will make some crack in the software, yes? Not like up to this moment. So everybody have to be safe, okay? So energy storage types, a lot of them. There are discussions which is better. All of them are very, very good. Of course, this is not natural friendly. However, thanks to this energy, we can move a little bit farther. And hydrogen, there are a lot of possibilities to produce the hydrogen from waves, from the ocean waves, from the winter, but a lot of people is focused on this. But hydrogen can be used not only to energy storage, but can be used in the factory to produce the steel, for example, to reduce the footprint, yes? How is it possible? By the converters. You can see the same structure of the power electronics. Inside, there are two transistors. The couple of transistors we are calling a power pole, and this magic power pole can control the energy flow and can supply your processor or processor in the computer of your son when they are playing of the game, yes? The processor's now consumes 100 amps in a peak, yes? In one line, there are 20 lines. A lot of power electronics and very efficient, very, let's say, convenient. This is very easy structure, known from many, many years, this structure, and this structure can be used in production of the green hydrogen. So let's say to go to the society and sustainability. Thank you very much for changing of my subject, because I was thinking, oh my God, what I can say about this strategy, yes? And I understand that we are engineers in most cases. However, everything depends on the demography, yes? On the people, based on our families. How we learn our children, we will proceed further. And this is the, let's say, strategy for us, yes? This is the history of humanity runs from the beginning and will run to the end through the family, yes? So this is how well we understand the problem, how we teach our children and our society. In Europe, we have a huge problem now because the demography is going down, yes? For industry is disaster totally, okay? So, and this is the speech from our leader from European Union. Not only engineering is important in the progress, we need support from the politician. Politicians are the most important because they are creating the rule and economic, yes? So Dutch insurance company introduced the discount just because if you are placed the green roof on your top of the house, okay? And of course, here you have a comparison. At the left side, engineering point of view of stability. On the right-hand side, political stability. Political means that allows us to introduce new technology. So just to conclude, we have a lot to do with our world. Thanks God, we have a beautiful world. We have to save this world, go to the service, and increase some innovation. Yes, needs interdisciplinary interaction. I learned a lot, yes, from other people, and to be honest, without our team, I can do nothing, yes? Education is important, and secure IT is important also, but not only this, because all high technology in our civilization need electrical energy. So energy technology is like a digestive system of our body. If works well, nobody cares, yes? But if something happens with your digestive, you cannot eat, you cannot, let's say, think correctly. So clean and sustainable world is expensive, but this is quite normal with luxury. So education, cooperation, and energy in different fields is crucial now. So again, come to Poland, and Shokran, thank you very much. Dziękuję for your kind attention.
Thanks, Professor Merrick, for your presentation and giving us insights on cybersecurity, power electronics, and so on, and renewable energy. Now we will turn into a case study of one of the Synergy. It will be presented by Jan Kiamakaki. He's the head of Synergy Coordination Office from the Fraunhofer Institute for Manufacturing, Engineering, and Automation. Jan actually was not able to be with us today, so we will have a recorded video on his presentation, and then he will be joining us as part of the panel. Just before we start the video, just a very quick on the Synergy project, which he's going to be talking about. It's basically investigating on how industry can actually help to balance out the fluctuation in renewable energy. And to do this, the industry must flexibly adapt its demand to the electricity supply, i.e. increase or reduce its consumption in a targeted manner without processes or product quality suffering. Are we ready to start the video?
Good morning from Germany to Oman. My name is Can Kiamakaki. I'm the head of coordination regarding the Synergy project, and I want to use the time for showing you some key results and the key concept of our project. First of all, I want to introduce my research institute and myself, of course. My name is Can Kamakci. I'm working at the Fraunhofer Institute in Stuttgart. The Fraunhofer Institute here in Stuttgart is specialized in manufacturing engineering and automation, especially in industrial companies. And one of our key topics in Stuttgart is definitely also to plan, implement and optimize the energy consumption in industrial companies to reach our climate targets that we have here in Europe, especially also in Germany. So what we saw in the last years regarding the market prices for 1 megawatt hour in the energy markets in Germany, but also in Europe, was a trend that the average price is increasing from just 30 euros in 2020 to 96 euros in 21. We of course had a regarding the energy crisis, we had an outlier with an average price in 2022 of 235 euros, and this was also decreased in 2023 to 97, 98 euros. Nevertheless, it is clear when you're looking at the left side and the right side that the variation and the spreads, the price spreads that we have during the day or during the weeks is way more higher than before. And one of the reasons, of course, is the volatile energy supply that we have regarding the energy that comes from renewables, such as solar energy and wind energy. And this is also the motivation that a lot of industrial companies that are also in our project have to optimize and adapt their energy consumption regarding the energy supply of renewables. And that is also the main goal that we have in our projects. The Copernicus project. The Copernicus project is a German initiative for mastering the energy transition. On the one hand, we have a project which is like more in a political way, how to adapt the society, how to adapt politics, legislation to a new energy system. We have a project Ensure, which is more into developing the grid of the future. PowerTalks is more technology or also a research project that is focused on storing energy in a long-term way in chemicals, in gases, for example. And then last but not least, also Synergy, which is our project, how industrial companies with their energy consumption can adapt to the energy supply. So this is also our main focus right now, to enable the industry to be flexible, to work on technologies that enable the industrial companies. Herefore, we got a lot of funding for all the 4 projects. And what is also really important and what was also a learning for us is to have enough partners, industrial partners that can also implement the technologies and the ideas that we have from research. Here, a small summary of the main goal of the project, which is also really, which didn't change since 2016. We want to create the technical and the market condition in harmony with legal and social aspects, that we can synchronize the energy demand on the one hand with the energy supply on the other hand. And this is also really important, or was really important for us, that we are not only looking into the technical aspects, because we have good engineers, we're building things, we're building technologies, that's the one thing. The other thing is also to look at what has to be changed regarding the legislation, regarding the regulatory affairs. I will come to that later in the next slide. So here, small overview about our main partners. For me, it's also important to say that we're having, of course, the automotive industry also in the project, but it is also necessary to not look only to the biggest companies such as Bosch, Mercedes, but also looking into small and mid-sized companies, where we also have a lot of different companies that are maybe small or mid-sized, but have a huge energy consumption that can be analyzed and that can be adapted as well. So here's also an overview about the different industrial branches that we're looking for so far. Like I said before, it's not only automotive, aluminium, magnesium, we're also looking into food or the beverage industry, which relies also on a lot of energy to produce, to cool down or to heat up. So this is kind of a strategic decision that we are not only looking into one specific industrial branch. We wanted to look into different industries that have different requirements for solutions that we develop. Of course, I also want to give you two different examples of processes or especially industrial equipment that we developed in the last year. One of them is a huge success, or was a huge success, is the bivalent heat supply in the metal industry. So what we did so far was to think about a metal furnace that can be used in for automotive suppliers. Here it's magnesium that we tried it, and the main idea was to say, okay, we can use electrical energy to heat the furnace, but we can also use gas to heat up a furnace. So why not combine it and use both in one furnace and optimize it in an automatic way, whether gas or electricity is in an economical way cheaper. And what you can also do with the bivalent furnace now is really to change in real time whether you want to use electrical energy as an energy source or natural gas. In a perspective, it should be also possible to use hydrogen, but this is kind of current research work in another research project. So it's not only natural gas, electricity, it will be also hydrogen that can be usable. So in the first example that I showed you, it was more into, okay, we're kind of changing the source of energy, but we're not going into the production process or into the manufacturing process itself. In the next example that I have here, it's about the paper industry, where we showed that also a manufacturing process with material buffers that I have in my process chain can be used to be energy flexible. And what we did with the paper industry is that we say, okay, we're using semi-finished materials to save them in material buffers that are already there, so there's no investment needed. The material buffers were in the company that we looked so far. There was a material buffer that we can use, and what we did was to optimize the production planning, to use these buffers for an energy storage, let's say it like that, an inherent energy storage, to be more flexible. And that was kind of a pretty nice example that energy flexibility can be in almost every manufacturing processes. If there is any storage of material, this could be also used. So it's not mandatory to invest or to buy in a new battery storage system. Sometimes manufacturing companies have also other possibilities to flexibilize their energy consumption. Okay, then what I was also learning from the project was, of course, you can have like a lot of different demonstration projects. You can have a lot of different examples around Germany to show, okay, energy flexibility is possible in the manufacturing world. But nevertheless, we also designed a model region where we not only have the manufacturing companies on board, but also have other relevant stakeholders such as politics, grid and network operators, but also the society involved. And the reason therefore is that, of course, energy flexibility in the industry starts in the industry. No, there's no way around it. But nevertheless, it is also important. I mean, we need incentives. We need the market that energy flexibility is kind of being invested in. So therefore, we need politics, we need the grid operators, and we need, of course, also the society. And what we did here in the model region was to focus on one region, focus all the projects that we have in this region with the context that we had so far, and to also bring politics and
apologies for cutting the video a bit short. I think we're running a bit out of time. I think we have 10 minutes or so, yeah, to try to finish and wrap up the first session. We'll just go through a few questions between all of you guys. Thanks for presenting the session, and maybe I'll start with you, Mariam. You presented on Oman energy transition, the strategies and so on. And we also have a path for economic growth and diversification. What do you actually see the main challenges we're actually having when it comes to energy transition and trying to also get into economic growth and diversification? And how can we possibly try to overcome these challenges?
Energy transition assembly is the transition from the use of the conventional fuel to the use of more renewable energy resources. And energy transition actually presents both opportunities and challenges for all sectors. Starting about the challenges, I think the main challenges, which is currently we are facing in Oman, is the challenge facing the conventional sector, which is reliant on the conventional fuels like oil and gas sectors and the employees in those sectors. Another challenge is the intermittent nature of the renewable energy, and also I think what to call it, the uncertainties in the technology development. The energy transition technologies are still developing, And there is a need to advance most technologies relevant to the smart grids, energy storage. And also, I think a challenge which might not be relevant to Oman is the challenges in the policies and strategies. We need to have defined roadmap for the energy transition with clear targets and objectives and the policies to implement those targets. And also the social acceptance is a big challenge in energy transition. Sometimes people might resist energy transition due to the perceived inconvenience of the energy transition. To overcome these challenges, I think, I believe upgrading and reskilling, training and reskilling people to shift them to more renewable sectors, and also supporting the investment in renewable energy and creation of the business relevant in the renewable energy and energy transition relevant industries will solve the problem relevant to the conventional energy sectors. And also for the the technology advancement and uncertainty, I think I believe also investing on the innovation and research will also solve this problem, and engaging the people on the energy transition decision and explaining their roles and responsibilities and the benefit they may get from the energy transition will also help in making those people accept the energy transition.
Thanks, Miriam. So I think it's quite what's quite clear from what you're saying. Public awareness, public on all of these transitions is quite important, because that's how it starts. Maybe I'll turn to Mahmoud and looking at the directions of 2040 vision. And we have mentioned obviously the increase of renewable energy, and there were several pillars we need to ensure. One of them you have mentioned, security of supply, reduction of electricity prices, and so on. Now, if we look, for example, at the renewable energy, and we understand their intermittent nature, and we would need some sort of means of, let's say, energy storage to ensure we try to have some secure supply. However, a lot of these technologies, and I think Dr. Hilal has mentioned several technologies, either they might be still on the expensive side, maybe they're not highly mature yet, and so on. And they might actually increase the cost, as a matter of fact. So how do you think we can balance all of kind of these directions? We're still looking at a secure supply, we will still want to reduce, but we also want to bring a kind of a stable renewable, in your opinion?
Thank you for your question. I think there should be a need for a clear plan between all stakeholders. Between all stakeholders. So this should be from a clear plan from the policymaker going to the regulator to implement it, and licensees also to implement it. So as a regulator, we have to balance between the government directions. We have to balance also that licensees have enough capabilities and capacities, and also to balance the interest of the customer. So this is why a lot of studies has been carried out. For the mix of generation, there are certain scenarios that has been undertaken. If we go with 10% increase penetration, 10, 20, 30%, what would be the cost to the system? So this has been studied by the authority, and to balance between the cost and the intermittency, I think a clear roadmap from the policymaker would help to manage this transition.
Thanks, Mahmoud. Maybe I'll turn to Dr. Hilal, and I think you have also mentioned actually on energy storage, and you have mentioned some of the technologies which you are currently shortlisting. I think there are 5 different technologies. But besides this, what is now the vision or the plan, let's say, with the NEMA power and water procurement to try to how we're going to be integrating actually these storage technologies? Because I think recently I've understand that one of the solar IPP, there is a provision, possibly there might be some storage into it. But what is there like a plan into place on when and how we'll be integrating those storage technologies?
As you mentioned, Mohammed, actually integrating something new to the grid always takes time to evolve and to absorb in terms of security, in terms of cost, in terms of mature technology. So what is normally our developments of a new technology, whatever, is in a very gradual manner. So as you mentioned clearly that in the new IPP, which is solar PV in Abri, we try to start with a small scale as a co-located storage just for frequency to minimize the ramp up and ramp down phenomena of the PV. However, based on our analysis and studies, that installing storage or especially lithium-ion battery on islanding mode as independent source is more preferable or more economically and technically preferable for the grid. And it is needed in very early stage, actually, based on our analysis, as early as 2028. We need this for like ancillary services, for spinning reserve sharings and so on. So we are exploring these options with our colleagues from the transmission grid about the locations, about the different type of ancillary services needed from these lithium-ion batteries. And then we start developing it gradually, as I said. There are many challenges and learning from our neighbors as well, especially Saudi Arabia, as we heard recently. They are developing a lot of storages all over the kingdom. But we will go for lower scale to learn and get the best benefits for the country.
Thanks, Dr. Maybe I'll turn to Professor Merrick. You've mentioned on some of the cybersecurity issues, and I think maybe it will be quite interesting to hear from you on what do you really think are the main cybersecurity threats when it comes to green technologies and how we can possibly think of them clearly and try to overcome them in a sense.
Thank you very much for this question. Really tough question, very good question. So Mr. Al-Lavati, I don't know, just to be clear. But I have some opinion, my, let's say, private opinion, and didn't not research it yet, I think. So the main problem is to protect the access to the energy storage. Why? Because if you have to understand, yes, everybody understands that mobile phone and computers without software are nothing, yes? If you will put your contact, for example, for my wife, children, this is a great value for me, yes? Because when I lost it, I lost something valuable. And with energy storage is something like that, we are not caring about too much if the energy is in the grid. But here in Oman, you have a very good, I think this is just on time, yes? You have some funds and you are rebuilding infrastructure from the scratch now, in the desert and so on. So you can predict at the beginning how your building should look like. So because cybersecurity is not only programming, yes? You can imagine if we are talking about energy storage in the size of power system, it is like a huge area. You have to protect this area because you can secure the code by the software, but if somebody enter, this is not cyber secure anymore, yes? That's why I would say cybersecurity is a key word in the science now. But to be honest, we shall focus on all of these smart bricks and connect in the proper way to obtain zero emission building, which is secure with good doors, and you can close and open intentionally, not accidentally. This is just my opinion. Thank you.
Thank you very much, Professor. Do we have any time to take questions from the audience? Maybe one or two questions? Yeah, okay. So maybe can we have a microphone to the, maybe we'll have room for one or two questions. If you maybe just mention your name and which organization you belong to.
Assalamu alaikum. Good afternoon. First of all, thank you very much. You were very insightful, all panelists. Thank you very much. My name is Abbas Zaidi. I'm the CEO of ELAF Technology Center, which is a spin-off of German University of Technology, affiliation with RWH Tiachen. We're 100% owned by Oman, but our affiliation and our governance is with the university in Germany. We started the cybersecurity program here and AI, and we're very much involved in the renewables. My question is to Merrick. When it comes to cybersecurity and renewables, we are a young country when it comes to introducing different types of technologies and academic programs. And one of the things that we do here at Geotech is we thrive and we're not afraid to be pioneers. My question to you is, when it comes to the cybersecurity in renewable energies, considering the stage that we're at right now, Oman is now the best time to start the cybersecurity programs or have a study or a pilot project with the academics to introduce them into this right now, or do we wait until it's more mature?
Oh. Thank you very much for this question and introduction of you. To be honest, everybody could start and should start as fast as possible. And if I could understand you, you are also cooperating with RWTH Aachen. So when I was there with Professor Rick de Donker in ION Research Center, to be honest, they have 4 levels in the ION Research Center inside, yes? So first level I don't remember, second level is power electronics, third level is IT technologies, yes, and cybersecurity. It was 10 years ago, so nobody was thinking about cybersecurity, yes? When I was a student, nobody was thinking about the cybersecurity, but we know that the program is something that we should protect. This is our mind, I would say. And moreover, if you are introducing this to teach people as fast as possible, we can understand more. To be honest, I'm learning from my older son now, yes? I'm asking him, what do you think about this solution, yes? He has a different point of view, really. This is maybe the answer to your question, if you are satisfied.
Thank you.
Thanks. Maybe we can have one last question.
Assalamu alaikum. I am Engineer Muhammad Al-Muhannadi from Qatar General Electricity and Water Corporation. Thank you all panelists for your presentations. My question is for Dr. Hilal. So you mentioned that you have some criteria to determining what is the optimal energy mix. So, and I noticed just now you mentioned that you also want to see this technology as it progresses and you don't want to jump too quickly into this new technology. So I want to know what is your criteria specifically in determining what is the optimal energy mix And if you implement any manual limits, maybe to be able to capture this immaturity in the technology. Thank you.
Thank you. Actually, the main criteria is actually 3 criteria, or 2 criteria, is the economics and the security. So we have 2 main criteria. First of all, we fix the security of the system. We should make sure that the system is secured whenever we install it. And then we keep adding these renewables to our generation mix until the levelized cost or the total system costs start declining. That means there's no more benefits of this adding more renewables in the system. So this is the economics and the security. We balance both, and we keep pushing the system until we reach to the optimum levelized cost or the total system cost as well. That's mainly. Also, we started with PV and wind. These are the main really resources available at the moment, which we can see they are economically affordable. And we keep adding also storages as an independent source for reserve purposes in the short term. And for longer term, we use it for energy shift purposes. So this is how we do our generation plan and our main selection criteria.
Okay, but to model this gradual increase in this new technology type, do you implement any maybe build limits, maybe for your capabilities and tendering these projects, or as you call the maturity in these technologies, or is it just purely the financial and security side of things?
For tendering process and the maturity of the technology is a must. The technology should be mature, and number of years is in operation, as we can say, before we introduce it in our system. That's another thing. But for the generation purposes, we have the targets as well of the government to reach a certain percentage of renewables in our generation mix. That's what we keep it in our mind.
Thank you very much.
Okay. Thank you all for your participation and insightful questions. We wish to have a bit more time, but unfortunately, we're already running out of time. So special thanks to our speakers for their valuable contribution. Please, a round of applause for all the speakers. Thank you. I think we'll have a quick break at the moment, 10 minutes, and then we'll come back at 12:45 for the second session, yeah? Thank you very much and have a nice day.
Okay, now we will start our second session for the day. Now starting our second session for the day, Power Systems and Grid Solutions, moderated by Ahmed El-Nadabi, Regulatory and Compliance General Manager.
Assalamu alaikum wa rahmatullahi wa barakatuh. On behalf of the IEEE administration, we would like to welcome you to the second sessions of today conference, which is basically about the power system and grid solutions. We have 6 presenters in this sessions. So this session, it might be a little bit longer, and we have a time where we need to manage it properly as we have a lunch break, and I don't want to hold you here for a long time. So I would appreciate from all presenters to watch and to manage the time. You have 15 minutes for each presentation, and then we have a 15-minute at the end for questions. So we'll start with the first presenter, who is Dr. Kai. His paper about the energy interconnection and energy transition in the MENA region. Dr. Kai was born in China. He is an economist and senior manager on grid interconnection at the Global Energy Interconnection Development and Cooperation Organization. His expertise includes MENA economic and social affairs study, energy resources research in China, Africa, and MENA countries. He participated in preparation of several GIRCO annual reports in energy transition, sustainable development in the MENA region. Dr. Kai has a PhD in Arabic study from Alexandria University, so he can speak Arabic as well. We'd like to welcome Dr. Kai to present his valuable paper, which is titled about the energy interconnection and energy transition in the MENA region. Dr. welcome.
Thank you, Mr. Ahmed. Assalamu alaikum. Sabah al-khair. Yes, just like Mr. Ahmed said that I can speak in Arabic, but today I would like to give my presentation in English about the energy interconnection and energy transition in the MENA region. So let me just try. Yeah. Okay, I'm from the Global Energy Interconnection Development Corporation organization. We are an international organization launched by the State Grid Corporation of China in 2016. We are focused on the energy transition and sustainable development all over the world via establishing the Global Energy Interconnection. So today, I'm so happy here. I'm so happy to be here to share my opinions about how the global energy interconnection to drive the energy transition in the MENA region. So the first part, let's talk about the energy interconnection in the MENA region. So the current situation of energy interconnection in the MENA region, as we all know, the MENA region is rich in fossil fuels and clean energies, and has a very advantage of becoming a global energy hub. And the countries in this region mainly rely on, unfortunately, so far, on the oil-powered electricity for the power demand, and while the electrification rate on the consumption side is still low. And according to the IEEE data, at present, the energy side accounts for about 55% of carbon emissions in the region. So energy transition has become the core content and the means of economic, social, and environmental sustainable development in this region. So in this region, fortunately, we can see that you already realize the 3 sub-regional great interconnection. One of them is the GCC states interconnection for the 6 countries, and there is 8 countries interconnection in the West Asia and North Africa. Also, we have the Maghreb region interconnection. So, and we have a very deep cooperation with the League of Arab States. So we think in the future this is a very important platform to to manage or to promote the interconnections in this region. So regarding the interconnection in the 6 GCC states, the interconnection has been implemented in 3 stages, and from the 2009 to 2011. This is very matured and very good interconnections between these 6 countries, and provide a very successful standpoint for this region. And regarding the 8 countries interconnection in the Western Asia and North Africa, so this region of these 8 countries is a key area for optimizing the allocation of Asia, Europe, and Africa clean energy and realizing the energy interconnection. Also, we can say there are 3 countries in this system is joint of the hub of the interconnection. They are KSA, Egypt, and Jordan. So we can see there are some designs for these 3 hubs, the Jordan and Egypt transmission line. Also, this 400 kV transmission line will be upgraded in the future to 1.1 gigawatts. And then the Egypt will export or transmit its power to Jordan and Syria and Iraq to solve the lack of the power of these countries. Also, the second one is the Jordan, the Syria 400 kV and 300 megawatts AC line was complicated. But now, because some reasons we can not operate it, and also Egypt has their vision and plans to do the interconnection with their neighboring countries to the we know to the west to upgrade the interconnection with Libya, and to the south to interconnect the transmission line with the Sudan and upgraded it to, I think, to 3 gigawatts. And also the interconnection with Saudi Arabia is under construction. Also, they have the plan. Have the plan to upgrade the interconnection with Jordan, as I mentioned. So regarding the Maghreb interconnection, I think the Maghreb interconnection is the one sub-regional interconnection in the MENA region to achieve or realize interconnected with between the Africa and also the MENA and Europe market. So as we know, the America and the Spain, they have 2 transmission lines, and now the third one is under promoted, and the Morocco and Algeria and the Tunisia, also the Tunisia and the Libya, they already have the interconnected line. But as we mentioned that because some geopolitical issues or some technical issues, there are some lines is not operated so far. Yeah, but we glad to see that the Morocco and Spain, they have the plan to build the third interconnection, and the Tunisia and Italy, they just finished the bid of the interconnection. So this is the second milestone for the interconnection between the MENA and Europe. So let's move to the PIM and the regional energy interconnection planning. So I think in this region, promoting the development of renewable energy is the most practical way to achieve the carbon reduction and sustainable development in our region. So the MENA energy interconnection holds a very position in realizing the Asia, Europe, and Africa interconnection, as well as a large proportion of renewable energy, just like solar and wind energy, connected to the grid and optimization of cross-border transcontinental allocation. So as the PIM designed, we can see the last plans to connect the 3 sub-regional grid interconnections, the Maghreb ones, the GCC, and the 8 countries interconnections. So there are 5 pillars for the PIM. The first one is the North Africa-Europe energy interconnection. It includes the Morocco-Spain interconnection, Tunisia, Italy interconnection, Egypt, Cyprus, Greece interconnection. Also, the second one is the North Africa and West Asia interconnection, is Egypt and the KSA interconnection. Also, the third one is North Africa and East Africa. We know there is Egypt and Sudan interconnection. So I think this is an interconnection to realize the power exchange between the North African and the IPUA countries. And also the first, we can see the West Asia and Europe energy interconnection. That's about the Iran interconnect their grids with the neighboring hosts. I think it's at least 8 countries around Iran. And the last one is the West Asia and the Gulf energy interconnections. We already know that the GCC states already have their own interconnections in the framework of the GCCIA. Also, the KSA had the plan to finish or to do the interconnection with Iraq to Jordan. Also, Jordan wants to connect with Iraq and Palestine to upgrade their electricity exchange capability after the upgrading with the KSA and the Egypt. So the building the global energy interconnection. So now, nowadays, we are facing the challenges to sustainable development. There are climate change, environmental pollution, resources scarcity, and poverty diseases. So the fossil energy dominated energy development patterns is unsustainable, and clean and low carbon energy transition is the trend of the future. So to overcome the crisis, we need to speed up the green and low carbon energy transition and establish a clean lead electricity core centered and interconnected, intelligent and efficient energy system. So this is what we initiated. It's the GEI, Global Energy Interconnections. So it's rely on the clean replacement, wide area interconnections, and electrification. So this is the we designed for the global energy interconnections. There are 9 horizontal corridors around the world. Also, these are 9 vertical corridors around the world. So let's move to the accelerating the energy transition in the MENA region. So as we know that the MENA region had unique advantages in the development of energy interconnection and the promotion of energy transition. So at present, great achievements have been made, just like we mentioned before. And the MENA energy interconnection is expected to become the 2nd mature regional power market in the world after the European market. And the MENA region should develop the scenic renewable energy, further develop the green hydrogen, just like the Oman and Saudi Arabia just did, and desalination, energy storage, and other industries. So we will realize energy transition and the economic transformation. So we think there are I think there are several comprehensive benefits for the MENA region to promote the energy transition. So the first one is promoting the energy transition in the region. The second one is promoting the economic transformation in the region. Also, the third one is building a new part of the energy security. How to build the energy interconnection and to promote the energy transition? We have 4 overall approach. The first one is to accelerate the development of large-scale clean energies and developing the solar energy basis in the Arab Peninsula and the Sahara Desert, and the wind powers in this region, just like the east of the Arab Peninsula, the coast of Red Sea, also the coast of Oman, and the coast of the Atlantic Sea. Also, we need to strengthen the power grid construction and the interconnection to strengthen the construction and upgrading of backbone grids in the MENA region countries and increase the capacity of cross-border exchange. Then to promote the construction of the trans-regional, even the trans-continent transmission corridors to the East Africa, Europe, and even the South Asia. So the next one is to consider comprehensively the need of green hydrogen development. So the hydrogen is the energy of the future. So this future trend to diversify the energy structure. So how to promote the green hydrogen development in this region is one of the most important issue for the power sector to supply the stable and green energy for the green hydrogen industry. So the next one is to improve the regional power cooperation mechanism. So as we know that there are 3 sub-regional market interconnections in this region, but it seems there's not one platform or mechanism to combine or to coordinate these 3 sub-regional interconnections. So we suggest to give full play to the organizing and coordinating role of the UN, the League of Arab States, the GCC, and the GCCIA, and institutions, and encourage countries to formulate policies and regulations conducive to development of energy interconnection. So, yeah. So this is my presentation. Thank you. If you have any interests and inquiries regarding the global energy interconnections, so I'm ready to hear your voice. Thank you. This is my email. Thank you.
Thank you, Dr. Kai, for the valuable presentation, and thanks again also for managing the time. Our next paper about the utilization of renewable resources for the ancillary services provision towards grid stability enhancement. The paper will be presented by Engineer Ikhlas Al-Waili. She graduated from Sultan Qaboos University in 2019, and recently she completed her master degree as well in the electricity engineering, specifically power energy engineering. We'd like to welcome Ikhlas Al-Waili.
Assalamu alaikum, everyone. It's my pleasure to be here in front of you, all experts in power sector, to present my presentation. It's about utilization of renewable energy resources for ancillary service provision toward grid stability enhancements. So through my presentation, I will deliver this subject, starting by briefing the background about the grid stability and the ancillary service. Then the objective of my research, the classification and types of the ancillary service in the power system topic. And at the end, the ancillary services that can be provided by renewable energy resources. So, as you all know, that recently the world are moving toward increasing the percentage of renewable energy and replace the conventional generation by these inverter-based resources. So, and this is due to the both economical and environmental reasons. So you can see here the table that shows the Oman target as presented before by the presenters in the previous section. Oman aims to increase the renewables, that is, contains both solar PV as well as the wind energy, to reach more than 30% in the next years, specifically in 2030. So this replacement of this conventional generation by inverter-based will change the structure and requirements of the power system. So it becomes a threat to the system operator to secure the operation of power system. So we need to find out solutions to secure the operation and reliability to deliver the energy for the customer. So my research is to study and analyze how can we benefit from these renewable resources to become as a provider of ancillary service rather than consider it as a risk to the power system. So the objective is to examine the various ancillary services by renewable energy, mainly the solar PV and wind energy, to stabilize the system dynamics and securing the power system. So first of all, let me begin by introducing what I mean by the ancillary service. It is a services or product that is other than delivering power or delivering the megawatt. So to benefit the system from different aspects, to deliver the needs and requirement and maintaining the security, integrity, reliability of the power system, as well as the power quality. And this is in a simple definition. Here we have the most common types or classification of ancillary service, which are the frequency control, ancillary service, voltage control ancillary service, and system restoration ancillary service. Let's start by the frequency control ancillary service, which is further subdivided into 4 main types. The first one is the fast frequency response, inertial. The second one is the frequency containment reserve, which is called the primary or group control. The fourth one is the frequency restoration reserve, and the last one is the frequency replacement reserve or tertiary. For the voltage control ancillary service, they are subdivided based on the system situation at that time. So either the power system is in normal situation or in a contingency operation. For the system restoration, the Black Start ancillary service is the main ancillary service to restore the system. So to make it more clear, these services now or currently are provided by the available running synchronous generator, which are the conventional one. First, I will describe these services that are supplied by the synchronous generator, which are the rotating generator. So you can see here the typical frequency response for the synchronous generator during the event of a tripping of generator. So at the moment of the disturbance, the synchronous generator will start to supply the inertial response, which is inherently available in its rotating rotor, to make the frequency nadir, which is the lowest point, as minimum as it can support. Then the droop control or the primary control will act as a collective action to the inertial response by the synchronous generator over a second. After that, the secondary or AGC will act to replace the primary control, and then the tertiary will complete the secondary by rescheduling a small and fast unit, which is mainly a task of the control engineers in the control centers. For the modern power system, which have more than 70, or for example, we have airline power system with 75%, they initiate a new ancillary service other than these four, which is called the ramping ancillary service. Ramping ancillary service, it's about how fast or the ability of the machine to ramp and reserve the frequency from going down during the events of the power mismatch. The voltage control ancillary service, as I mentioned before, it is divided based on the system situation. Either it is defined in the normal or in the contingency. For the normal or the steady state operation, the voltage control ancillary service used at the steady state operation to maintain the voltage within the specified boundary as the standard. For the dynamic situation or the contingency operation, this ancillary service is responsible to fast inject the current to preserve the voltage from falling down during the contingency, then saving the security of the system as well as the power quality. This graph shows the capability curve of the synchronous generator. Either it is supplying the megavar or absorbing the megavar. The third type of ancillary service is the restoration, which is mainly the black start ancillary service that is provided by some synchronous generators to start delivering the power from zero when the system in a blackout and without taking the auxiliary from the system. So now we move to the ancillary services, mainly the frequency control ancillary service that can be taken from the renewable, which are, as I mentioned before, solar PV and wind. Here I divide it into two types. Either it is connected to the energy storage system or it is not connected to the energy storage system. So for the solar, because it is a static generator, it does not have any rotating part, it can be, the deloading technique can be used to have this frequency regulation service from PV by making this solar PV plant to be run lower than its maximum power point. So maximum power point tracking. So we have like a reserve by which is by adding the additional controller. So when we have such a contingency or such a drop in the power or power mismatch, this reserve can be supplied to the system, and hence this PV plant can support the frequency at that time. For the wind turbine, which is different from the solar PV, it can, there are three techniques to be used: inertial, droop, and deloading. For the inertial, there are additional two controllers. First one is the hidden inertia, and the second one is the fast power reserve. They are different from each other, that the fast power reserve have a specified percentage set. As I found it in the literature, it is set by 10% constant. The drop control is for primary, and the deloading, it's the same as the solar PV, which is making the reserve from the wind to be participating in the frequency. For the second type are with integrating the energy storage system, same as these techniques, but with the addition of the energy storage system. So I summarize some pros and cons for these techniques. For the wind and solar without ESS, the deloading can be used, but with the disadvantage of that you will ignore a free energy that can be supplied by these renewables and used for such contingency events. But with the addition of the energy storage system, these techniques will enhance further. It will increase the reliability of the frequency support with the disadvantage of the cost of the energy storage system. Here I mentioned some international implementation of such frequency control ancillary services from the renewable. As it is mentioned in the table, the Ireland power system have a 39 megawatt used for frequency control from wind. And for the national grid, the wind farms also are, it have to have a capacity of, it have to support the frequency control if its capacity more than 50 megawatt. So in conclusion, the frequency control ancillary service or the voltage control ancillary services can be supplied by the renewable energy resources with the addition of controllers and additional of the technologies added to these renewables to be a provider for ancillary service. Thank you.
Thanks, Ikhlas, for the presentation. Now we go to the third presentation, which is delivered by Siti Aziz. Siti Aziz is a consultant in electricity market and regulation with nearly 10 years experience in the energy sector. Her expertise spans in management consultancy, business analysis, stakeholder management, techno-commercial aspect of energy systems. She has MBA in the energy management from Technical University, Berlin. We'd like to welcome Siti Aziz to deliver her presentation.
Thank you very much for the introduction. Assalamu alaikum and good afternoon, everyone. So the best thing about presenting in the afternoon is that, a lot has been covered in the morning, and people are probably a little bit sleepy after lunch, so probably half listening. So I will try not to bore you too much and give you some insights. And I'm also aware that I'm in a room full of electrical engineers who probably knows the Omani market better than myself. So just to mention that this presentation represents a stock take of what we can find from the open data sources, and I'm looking forward to learn more from everyone in this room to refine our understanding. Right, now the disclaimer is out of the way, let's get delve into the matter at hand. Right, so it's great to see that Oman is diversifying the energy mix, so there's definitely a push for renewables. We've heard about the ambitions, but the current state is around 6% of RES, where 92% is from solar PV. That's around about less than 1 gigawatt, unless I'm mistaken. So let's see some updates later on. But 94% is definitely from fossil fuels, regardless to say Oman is abundant in gas. There's a year-on-year growth of 3% for electricity demand, as we've seen in the presentation this morning, but with a 4.6 million inhabitants, 5 million. So I think Oman will remain an net energy exporter. So, and we could see the transition goals, 16 to 20 gigawatt RES by 2030. That's green, mostly to support the green hydrogen ambition, which is very interesting in this country. And the free up gas will probably be sold more competitively for LNG revenues. And we heard also this morning from 40%, so it has to be updated to 70% of target for electricity RES by 2040. And of course, we are aware about the net zero carbon 2050. So just mention on the map on the left side, please read this. The disclaimer is actually a self-drawn map, and it doesn't represent the full picture, of course. But just to give a representation on the infrastructure growth, that's great to see that there's an effort to connect the north and the south. Also, we see the GCC Interco with UAE. I'm not sure if this is done, but according to my sources, still in plan. That's 400 megawatt capacity and 220 kilovolt DC connection. This is great because, as we learned from the EU case, the cross-border grid systems will enhance the flexibility and stability of the system. So hopefully in Oman, it will definitely play the same role. Now, these two slides I will just briefly go through because we all know about the massive solar and also wind potential here. Just to mention that on the source by IRENA, actually Oman shows the higher end of the megawatt hour for the solar PV generation compared to the world benchmark. So this places Oman as a potential regional leader in this case. Of course, we are also aware about the ambition of hydrogen, where Oman would like to produce it from solar PV. But the question is, how would it be used? Is it locally, or is it going to be redeployed as long-term storage mechanism, which is key to unlock flexibility, or eventually for export? But that's a question on commerciality, whether there's infrastructure for that as well. Yeah, so we could see the solar PV potential is peaking in the north and the south. And as we heard this morning, new projects are coming, like the Manna, Ibrid 3, and Al Kamil, according to our sources. So next is wind. Similarly, for wind, there's high potential as well for Oman, according to the world benchmark, particularly in the southeastern region of Dhofar and Al Wusta. So as we understand, the 50 megawatts in Dhofar already operates since 2020, the wind farm, and 2 more are planned as per the map. So here, what I wanted to mention for wind and solar is the criticality to manage the intermittency and grid balancing. Regardless to say, you've heard about all this. And we could also see, because the load is normally in the coastal region, in the north and the south, and with renewables, the production will be further and further away from generation. So like in the deserts or in the coastal areas for wind. So there's a need to reinforce the grid. And we've seen this in Germany. I believe we have Siemens people in the room. Maybe they can concur. Like you have a lot of offshore wind in the north, and the demand center is mostly in the south, so there are some congestions problems that has cost billions in energy curtailment, particularly renewable energy curtailment. So taking steps to prevent this in Oman would be wise, which is to think about flexibility in the grid, storage, etc. Right, so just a quick overview on this, and I'm aware that there has been updates as well we've seen this morning. Because we've seen the ambition, potential, and now the policies and regulation will unlock this potential. There is the push for renewables is definitely underpinned by clear legislation. We've seen 2004 is a critical thing with the Royal Decree of 78, where it allows and encourages private sector participation, and the creation of AER, and I'm aware it's been renamed to APSR, in 2020, as the Independent Regulatory Authority is a great step as well. And the generation around 2000, we see generation in MIS and DOFAR have been privatized, and also there's privatization of transmission and distribution. 2022 onwards, the famous spot market. Yes, I actually would like to get more information on this. So it has been launched apparently, and in 2023, a very good development also on the Royal Decree of 10 shows the more push towards hydrogen and renewables that says the ministry has full control of green energy and hydrogen, including land allocation. And by 2030, there is a push as well to reduce the subsidies and shift to cost-reflective tariffs. So what I wanted to say from this slide is there are elements of market liberalization in place that would definitely support renewables growth in the country. So, yeah. And now also this slide, I'm so sorry. I know Dr. Hilal has presented an updated one, but I couldn't amend it anymore. But this is the market structure that we try to map and understand for a more holistic view. So APSR is a very important role here to protect the interests of consumer market participants, public interests, and also government policies and objectives. So we have the MIS and DOFAR, and the bottom is RECO, which is no longer horizontal, as per presented today. And yeah, so it's also no more a lot of distribution and supply, but just one supply and distribution company. But what's interesting here is the market launched in 2022, so we'd like to understand more of the role here. But so the market mechanism is supposed to allow generation companies to sell surplus power at market prices. So it's a great step to encourage more and more renewable investors, as spot market also represents another revenue stream for them. And this model, but if it were to be run by the single buyer, which is NAMA PWP, no longer Oman, then it might be presenting some challenges, as I will present in this slide. So so from the start to end, this is just our summary of what we think. And of course, this is further in-depth studies, but overall, the positives are that there are steps to liberalization in Oman. It's quite progressive, we could say. Clear and transparent regulation also to spur private investment. APSR, as for example, APSR as the independent regulator. Then the regional interco will also lead to market integration. Right, so in terms of the challenges, well, we have the single buyer model. So the transition to a fully liberated market will see that this might cause some sort of conflict of interest because a single buyer is always pursuing to procure electricity at the lowest possible cost. And the market operator's rules is to ensure the more fair and transparent market. But we've seen, like, for example, in countries like Senegal, there is a phased transition that could happen there. Infrastructure gaps here, I wouldn't say it's just a case for Oman, but I'm saying, I mean, they're having great steps. We've seen connecting the north and the south grid, but just in general that the grid needs to be fortified to have more renewables, like we will have distributed energy resources, DERs, etc. So potentially also more interco should be established to ensure system flexibility and redundancy. Then we have the key questions for grid alignment. We've heard the storages could be co-located or investment in the grid can be expensive for the end user. So there should be some considerations over there. Also, last but not least is something that's been talked about at least 2 to 3 times this morning, the challenges in flexibility and frequency. And I believe I don't need to repeat what the famous duck curve means with the high RES penetration, especially with solar. But Just 2 points, or 3 points actually. So the thermal power plant has to cover the base load and able to ramp up quickly. So this is flexibility on the supply side. And number 2, the flexibility on demand side. Well, to avoid curtailments, then you could have flexible appliances. I'm thinking about, like in the case of Europe, it's heat pumps, but here could be air conditioning, for example. It's just the reverse of heat pump. So, and there also must be incentives for energy usage based on generation. And the third one is storages. We've seen a lot as well today, the batteries, the EVs, and long-term storages could be in the form of hydrogen. But the high-level takeaway in this slide would be high flexibility will allow for more power usage from renewable sources, and low flexibility will result in high RES curtailment. So yeah, when talking about curtailment, normally the cost will be socialized to users. And also if Oman were to attract more private investors for RES, then this could deter. If there are no, payments or green schemes that would deter private investors as it impacts their business model. So that's why we are at IEEE Group. Sorry, just a message from the sponsor. With our background in TSO in Germany and Belgium, so we have provided consultancy and advisory to solve many power system challenges. Particularly in Oman, we could see there could still be solutions to challenges in managing the green grid, the market design, for example, the smart grid, flexibility and reliability. But something that's probably not covered and may be relevant as well is the offshore, not offshore, but electrification of oil and gas facilities to produce more carbon abated volumes. Just to mention, we are present in the region. We are in UAE and Saudi. So please keep in touch, and I hope to speak to you in person later on. Thank you.
Thank you, Siti, for the presentation. It was very interesting. Now we move to the fourth presentation with Dr. Ralph. He is a senior vice president with Siemens. He is responsible for the grid software businesses in the Middle East. He is also responsible for the grid operator industrial across the Middle East in the transmission distribution control centers, EMI, grid planning, microgrid, EV charging management. He has a PhD in the thermoacoustic and also diploma engineering in the aerospace with major specialization in the fluid and thermodynamic. We'd like to welcome Dr. Ralph to deliver his presentation.
Thank you very much. I figure thermoacoustics nowadays with renewable generation is not that en vogue anymore. That's why. Let's talk about the hot stuff on the block. Thanks a lot for having me. It's a big honor to be here, and I love being in Oman because there's just so much happening at the same time. And the dynamic I feel here, also in the room, is really inspiring. So allow me to share a couple of thoughts around renewable integration, which I think is one of the key elements that has been alluded to more than 100 times today. I didn't count, but I think that's one of the big points. Siemens in general, and we have our CEO in Oman sitting here in front of me, has a long tradition not only in Oman, but also in the Middle East in general. And we are very proud that we can commit to being Oman's energy transition partner. So there's a big history to that and a lot of engagement beyond also the IEEE. So, yeah, Oman takes it serious. The whole net zero strategy, the whole hydrogen strategy, the buildup of renewable sources, the build out of transmission grids, distribution grids, smart meters, etc. I mean, this is really, really ambitious. And I'm not going to go into all the numbers because we've heard multiple times today. It's just that the challenges can't be mentioned often enough, right? If we really move into that direction over the next couple of decades, the missing inertia, the interconnection requirements, the dominance of inverters, and we had some very expert talks earlier today about this. The sheer number and complexity related to DERs, I mean, this is really something we must not underestimate. And still, we see the projects moving, and that's good, because only once they move and force us to react, I think the utility and the grid operators here in the room can really take steps together with technology partners like Siemens and others in the market. But it's really something we tend to talk lightly about. You see this graph here on the slide. This is how we depict typically, or to try to quantify the complexity that's coming along. Right? I mean, you can call the y-axis capacity, you can call it distributed energy resource hosting capacity, you can call it generally management complexity of a power grid. No matter what you call it, this is increasing exponentially. And the problem with exponentially is, as you know, you don't see it coming, because once you see it coming, it's too late. Right? So once the curve goes up, you're in it. So are we really further on the left, on the right? Doesn't matter. We are heading towards the right. And with all the investments that are coming, and billions are pouring into the Sultanate, there's a certain speed associated to how fast we can build out the grids, right? And that's what you see with the linear conventional investments into power grid, which are absolutely necessary. But to fill that gap of how fast it's changing versus how fast we can react from an infrastructure point of view, there's definitely what we call the hosting capacity gap, which is something where we see technology and skill set and mindset of utmost importance. So if we want to close that gap, if we want to make the transition happen, we need to rely on technology to make use of what we already have in our grids and make that more efficient. And this requires a paradigm shift. And that's actually what I'd like to transport today, because the way we've been seeing if you can go to the next, oh sorry, I'm clicking on the wrong one, sorry. The way we've been seeing grids in the past is top-down, right? From generation to transmission through to distribution and the end users. That's of course still the way we're set up, but in terms of how we need to think moving forward, in terms of where the innovation is happening and will be happening even more strongly over the next 20, 30 years, it's actually flipping the perspective by 180 degrees. And that's tough, especially for our colleagues in the room who work on the distribution side of things. The pressure and innovation pressure that's coming up for you guys is immense, because we have millions of elements entering the grid that we didn't have previously, that we have to manage, that we have to develop our skills to entertain, to keep the whole system stable. And it's not like it was in the past, that what happens on distribution is just a little crumble, a little digit after digit. It's actually something that will have an even bigger influence on what happens back on the transmission side of things. So this is the fundamental change we all in the room here have to stand for and work towards, because we cannot avoid it coming. And that also means a lot of technology needs to change, right? We're coming from an age of, we call it copper plate, right? Old SCADA systems, which now in some cases are already replaced by ADMS or DMS, ADMS systems. But where we really need to work towards over the next decades is to move towards autonomous systems. That doesn't mean that we're getting rid of all of us. It's the contrary. We need to upskill to be able to manage those grids that are autonomously managed by technology, because simply human, we cannot do it anymore. If we look at millions of elements that need to play together, it has to be more technology-driven, recommending to humans rather than humans using it on the side. Now, you've probably heard this before, right? Either by competition or some other players in the market. So I'd like to go into one example of what that actually can mean, right? Where we can already harvest that technology today as we speak. You don't have to wait for it. And this is the example of, and I'm going to jump over this. This is just repeating what I just said, right? To look at how can we actually monitor and improve the integration of DERs into the grids, right? And one very important aspect on that is what is actually the impact of integrating renewables at large scale on the technical losses, because ultimately that's then cost to the system, and we want to avoid that, of course. So, and we shouldn't say it lightly also, because if we look at the magnitude of technical losses that we have across the Middle East, varies of course from country to country, from grid to grid, but definitely we're talking about if we manage to reduce technical losses by just a couple of %, we're talking power plants of investment saved. So it's making more out of what we have, squeezing more out of the existing to bridge that gap of the time until the new investments kick in. Right? And so I'm just going to take a simple example. Right? This is a feed where then traditional planning means, right, we would take static data to calculate the losses across this feed. There's a transformer, there's a couple of users, right, and there's a certain loss associated to it. Fine. Now we have EVs coming in. So some people might want to charge at home. We add the chargers. There's a certain additional load, but that changes the pattern of losses, of course, right? Static calculation gives us slightly higher total losses. Then there might be generation added, renewable generation added on one end of the line, okay? So we can calculate again. The impact is that losses get reduced in this case, fine, but that's one scenario. Like another one, maybe we want to add even more. Okay, so we now have 4 different scenarios, which according to static planning needs will give you some kind of consequence in terms of what that means in terms of technical losses for the overall system. Now that's one way of doing it. But do we actually know that that's the right way of doing it? If we now imagine this to multiply across an entire distribution grid and we have to recalculate all feeds where everything is changing at the same time, are we really sure that we're hitting the nail to see where we actually need to improve and the grids, make them more robust, make upgrades, etc.? Well, I don't think so. Because if you look at how you could do it otherwise, by using, for example, data that you're anyhow measuring from the smart meter rollout that is happening in Oman, you will see that there is quite some benefit, or that can lead to quite some changes in how the results that we're getting from these planning calculations. So here's one way of using meter data, feeding that into the same models that you use on the planning side, and then redoing calculations on the planning side based on actual data, actual consumption data, time of day use, etc., versus static data. And this, you will see now, gives you very different results, as I just said, and that has a business case, because that can really pinpoint the investments that you're taking into the grid to a much better direction, save money, and also increase the speed at which you can act. So smart meters, the meter to cash that we see from revenue collection, that's one thing, that's a necessary thing, but that's not what's going to give you your money back as a utility or as a country. What's going to give you the money back is the additional use cases of using that smart meter data for other instances in planning and also in operations. So here's the same thing now again, but with the meters. And we see that each of these scenarios that I introduced before has a very different profile across the day. And associated to that, very different losses. So here's the different scenarios that we had according to a static planning or static loss calculation. If you then add the actual usage or the metering data, you get a very different profile. And that's what I was mentioning earlier. So is this better or is it worse? It's more accurate. And given it's more accurate, it gives you as a planning engineer and as a utility more accuracy in then planning out investments into the grid and where to really pinpoint. Because each of these scenarios has a completely different loss profile, and each of them then can lead you to very different consequences in terms of what you now want to do. So for example, this is just one example, it might turn out that given that I have the 15-minute interval data, I see that a certain transformer is overloaded certain times of day, and that's why that scenario brings us very high losses on average. Well, if you know that, well, the software can pinpoint to you, okay, that's a very good investment, because if you upgrade the transformer, you will have a return of investment of, I don't know, 3, 4, 5 years, for example, rather than doing a statistical analysis on where to perhaps focus, which is a lot of work. Right? So here the asset replacement has a business case in itself, and it is possible because you're simply connecting elements that anyhow exist, right? A meter data management system with a planning software, with perhaps an analytics front end that you could use, right? And putting these building blocks together to get more accurate. So this is one a way of seeing what the transition actually means in terms of technology requirements, and where we have to make use of it to gain speed and to save investments for where we really need them. So I'll leave you with those thoughts. Thank you very much for giving me the time. I mean, this is just a summary of what I basically just said. If you allow me, do I have one more minute? Okay, because then I would like to use the opportunity to introduce, let's say, our response to this challenge. So basically a summary of what I was just saying with our new portfolio brand that came out. It's just a 1-minute video, summarizes what I just said in the last 15 minutes on a much more general term. So please, if we could have that video, please. Thank you very much.
Thanks, Dr. Raf, for the nice presentation. Now we go to the 5th presentation, which is about the challenges of the high penetration of renewable and impact of multi-level STATCOM and grid forming control. The paper will be presented by Abdulaziz Makwar. He is responsible for the power quality solutions and sale and marketing in the Middle East. He has been involved in many projects and developing multi-power quality solution project in the regions for the utility and renewable applications. He is a master holder in power engineering from the Royal Institute of Technology in Stockholm, and he has also a bachelor degree in the electronics engineering from Simon University, Canada. We would like to welcome Abdulaziz.
Assalamu alaikum, everyone. This is Abdulaziz Makwar. It's really nice to be here in Oman. It's my first time, and I really like the place, the people. It's amazing, and hopefully, for sure, I'll come again for tourism, not for work next time. And I'm going to talk today about the challenges that we're facing with the integration of renewable energies to the network and the technologies and solutions developed in the market to avoid or to mitigate the issues that we see with these new technologies. So we've been talking, in the morning with for the changes that we are seeing in the in the market, from the generation side to the transmission to the distribution. So we are integrating new renewable energies and we're decommissioning older generation. From the consumer side, we're seeing new loads coming in. With data centers, with e-mobility, electric cars, with trains, and so different loads are coming out. And also from transmission side, we have distribution generation, so we have transmission from different locations where we didn't have generation before. It's getting older, we're changing the grid compliance as well. So all of these changes actually need good power quality. And this is what we're gonna talk about today. So what kind of services do we normally need to operate a stable grid? We have inertia, system strength, frequency control, and voltage control. Different technologies can actually do these type of services. As you can see, synchronous generators are one of these technologies, the old conventional generators, which comes inherently with, it gives inherently these type of services. But as we decommission those and have more IBRs and inverter-based solutions connected to the grid, we will not see these services coming out from those synchronous generators anymore. So we need to develop or add to the network other solutions as well. And I'm going to talk about the what we call them the FACT solution, flexible AC transmission systems or power quality solutions. I'm going to focus on the STATCOMs, enhanced STATCOMs, and synchronous condensers. And just a little bit, I believe also all the colleagues before discussed this. So the main issues that we see with the integration of renewable resources is system strength, the short circuit contribution, and inertia. And just a small definition for system strength is the ability of the system to maintain voltage stability or to manage voltage stability. And the inertia, it is the same, but for frequency, is to limit the rock-off, the rate of change of frequency. And as we decommission the old generation, those are going down, system strength and inertia. And with reduced system strength, we'll have lower voltage stability. We will have higher voltage dips. Also, relay protection might not be able to detect the short circuit current. So system strength is a big issue if we didn't handle it carefully. Inertia, it's the same thing. We are missing rotating mass in the network. So it will impact the frequency fluctuation into the system, so we need to find ways to increase the inertia in the system to maintain frequency stability and reliability. And one of the technologies is the old technology that Hitachi Energy we've been working on is STATCOMs. So STATCOMs is an older technology. It started, I think, early 2000s. And the old STATCOMs, the traditional STATCOM, it was 2 or 3 level converters. And it has multiple branches, smaller branches. It was costly, and it used grid following control as well. And with the development of technology, so the technology of today, what we did is we have the multi-level STATCOM converters, and with this multi-level converters, you can reach higher STATCOM rating, which can regulate the voltage at different locations in the network, at different voltages at the network. And in addition to that, we built the grid forming control for our STATCOMs as well. And with grid forming control, you can operate at lower short circuit levels. And with the integration of renewable energy and the reduction in system strength, this will be crucial for today's STATCOMs. In the future, STATCOMs, as you know, only give reactive power, so it doesn't give any active power. But in order to control the frequency and to increase the inertia in the system, you will need an active power source. So the concept here is why not to add an energy storage system to the STATCOM so that it can contribute to the frequency support as well. And here we have the enhanced STATCOM, where you can provide active and reactive power to the system. It will be connected in double Y, and it has supercapacitor as the energy storage element here. And this is the STATCOM of tomorrow. I don't know if we call it tomorrow because we're already actually we're executing a couple of projects with the enhanced STATCOM. Just a little bit on grid forming control. So as you know, electricity will be the backbone of the energy system. And as you know, grid forming control, we as Hitachi Energy, we've been working on developing our STATCOMs to meet the future's grid requirements. And the future grid requirement means that the STATCOM should be able to work at very low short circuit power at PCC points, and also contribute to the strength of the system by providing short circuit power, short circuit contribution. So with grid forming control, the STATCOM will be, you can say, sustainable and will support into integration of more renewable energy and will support the reliability and stability of the system as well. Just a few points on grid forming specifically. Grid forming is not yet defined in trade association. There is no clear definition of grid forming. But what we are doing here, or what we say that grid forming should do, is instantaneous support to the grid to maintain the stability. And one way to do actually this is to make the STATCOM behave as a voltage source behind an impedance. And with this voltage source behind an impedance, the STATCOM will be able to actually form or create the voltage in contrary or in comparison to the other grid following STATCOMs, where it needs a firm voltage from the system. So the STATCOM will create the voltage. The STATCOM will be able to support during the faults, not post and pre-fault. Also, the STATCOM will support the system during fault in positive and negative sequence as well. And we will limit with the, when we have a lot of IBRs and also reactive power compensation solutions in the network, there might be an interactions between these solutions. And grid forming will limit this type of interaction between the IBRs and the reactive power compensation solutions. Just a slide, we're talking about grid following and grid forming. Grid following is the solution that we have right now. We're actually doing both as of now, but mostly we're going into grid forming. So grid following is the older solution. So the STATCOM, in this case, the converter, the control system will be viewed as an ideal current source. And it uses a PLL-based control system. And with this PLL-based, you will need, as I said, a firm voltage from the grid. And a firm voltage from the grid with the integration of renewable energy might not be there. That's why grid forming become essential in this case, because you will need the STATCOM to work in a very weak network conditions as well. And another point is the instantaneous support of voltage. With grid following STATCOM, there is no instantaneous support or limited instantaneous support during the fault. With grid forming, it is there. It can support during the faults and will limit the voltage drop in the network due to faults. And as I said, grid forming control, it is viewed as a voltage source. Projects and service, and more to come, and we view it as the technology of the future, or the control system for the future for the STATCOMs as well. To the case what we have in GCC countries, where we have a lot of air conditioning, and with air conditioning, with the induction motors, you will have something called the fault-induced delayed voltage recovery that will come post a fault. And with grid forming control, it can support this and limit the voltage drop because it can instantaneously support during the faults. So it will limit. So it supported the grid there. And I'll go past. This is another offshore wind project in New York. And the PCC point where we're connecting the wind farm is low. The SCR, there is low, the show-circuit ratio. So STATCOM there with grid forming can contribute this and strengthen the show-circuit power at that point, and will be operating normally opposed to a grid following STATCOM. Frequency support element of it, you need to have energy storage element, and for us here it's supercapacitors that we use for this type of support, and in this case STATCOMs will actually support in voltage regulation and in inertia and frequency and short circuit power contribution by having the active power element. Here, we already discussed the challenges with system strength and inertia. And here I'm just gonna talk briefly about the comparison between the technologies. I mean, STATCOMs and synchronous condensers and what we call it SVC Lite, which is our brand name for STATCOMs. So enhanced STATCOM. And as you can see, for voltage regulations, STATCOMs and of course SVC Lite will have a better voltage regulation compared to a synchronous condenser. Because of the physical limitation on the synchrons. For inertia, actually, the SVC Lite enhanced, because it's providing synthetic inertia with the supercaps, it can provide fast frequency response, which can be better than syncon here. Also short circuit contribution, of course, synchronous condenser can provide 4 or 5 times the overload, so it has the it's superior to an enhanced STATCOM with supercaps. However, the point that I want to show here is that with enhanced STATCOM, of course, you can provide that, and with STATCOM with grid forming control, you can provide short circuit contribution as well. I'm running out of time, so I'll try to go fast. I have more couple of slides. Here about the, just want to mention the energy storage part of the enhanced STATCOM. So there's 2 choices, supercapacitors or battery energy storage system. And we have a rule of thumb that we say between, if you need megawatt support to be short for 1 up to maybe 10 seconds, supercapacitor will be the economical solution to be included with the enhanced STATCOM. More than that, a battery energy solution would actually be more economical. I don't want to go through a lot here. So here, and this is actually the first project that we have. It's 2 projects in Germany with enhanced STATCOM. It is it's already, under execution. I think the energization will be in 2026, and it will support with active and reactive power to the grid. Last slide here. One solution that we've been working on as well is the combination of a couple of solutions, so synchronous condensers with STATCOM. And with this hybrid solution, you can get the benefits of both technologies. So STATCOM can have the fast voltage regulation, and syncon can provide short circuit power and inertia to the network, while actually reducing the size of the syncon to reduce the losses and increase the STATCOM size as well to regulate the voltage. And we have a reference already here. This is in Scotland. This project was energized in 2018, I think. So it's been a while. It's an open source, actually. If you click on the link that you see after you get the handout, if you see it down below the picture, you can go to all the documents related to this project. And also we have another one that's under execution. This is also in Scotland as well, with the same utility but larger scale. And with this solution, you can provide inertia source power from the synchronous condenser at very, very low short circuit power area, and also the voltage regulation from the STATCOM. So that's my presentation. Thank you.
Thanks, Abdulaziz. It was a very interesting presentation. We hope have much time so we can give you, but we are limited to 15 minutes. So now the last paper, which is the voltage source converter representation for efficient and credible RMS studies. The presenter of this presentation is Dr. Graham Philip Adam. Adam is a principal planning expert with NEOM Energy and Water in KSA. He is a technical lead for 3 gigawatt and plus or minus 525 kilovolt bipolar voltage source converter. He has a long biography and rich achievement. Dr. Adam is an author and co-author for more than 100 technical reports and books. He has a publication over 150 journals and articles. Hundreds of those articles has been appointed as the highest cited articles. He is a member in, he is a senior member in IEEE, and he is also a member in the editorial board of IEEE Journal of Emerging and Selected Topics in Power Electronics. He received a number of rewards and recognitions for his valuable contribution. We would like to welcome Dr. Green to deliver his presentation.
Many thanks, yeah. I think I'll take a slightly different approach. I better be there. Which one is the pointer?
Yeah, better to be for the mic.
Yeah. No, I need the pointer. I need pointer. The middle one.
Yes, the green button.
Okay. My name is Graham Philip Adam. I'm from NEOM Energy. So I want to talk about the VSC, which is voltage source converter model. The purpose of the presentation, because today, at least in recent years, I can see increased penetrations of PV and wind farm, and these are likely based on voltage source converter. And that actually brought a lot of urgency. We should have much better models. The purpose of having much better models, because planning is very important stage in every project. So if you have better planning, you can save a lot of money, which means actually you can avoid overinvestment. If you have some wrong models, you have a bigger risk. Either you overinvest, putting asset not needed, or you also underinvest. So this is and this is the background of my work. Today, in power systems planning, or at least through the project design stage, we use RMS. RMS, it has some limitation, but also it is indispensable. It gives you a little bit the key information to do the projects. And for example here, you can give you a little bit some preliminary information, indication if I need some additional reinforcement, if I want to build a wind farm or the OPV and so on. And also give you some key data you need to start the projects. These are still a crude data, but through design stages you refine that data, and then you're getting better in your design. And also it has good speed, which means actually you can scan large number of cases to be able to pinpoint what are the key problems and so on. These are clear advantages. But with the energy transition, with increased penetration of power electronics, it faces a lot of challenges. And the way to overcome these challenges, different utility today using different approach, which has no scientific basis, but driven based on empirical evidences. Sometimes you can say antidotes. Some of them work to some extent, but it have some deficiency. And here is today, if you can see today, most of the RMS only include positive phase sequence. That may be good for the past, where the grid was likely dominated by synchronous machines. Today, we have the grid likely driven by converter, which actually, instead of synchronous machine, you only control a positive sequence. Now I can control a positive sequence, a negative sequence. So if my model today exists only positive sequence, which means actually I don't have a full picture how grid work. So I need a little bit some better way of doing that. And also when the system strength going down, most of the today RMS model actually diverge from the actual behavior. So you're at risk of deciding, okay, I need a STATCOM here, which is actually you can live without it, especially today with the advancement in converter control, which is grid forming, different implementation of grid forming. You have a lot of possibility to operate, allow SCR without needing STATCOM or synchronous condenser and so on. So there's a lot of benefit of having that. For utility, you can save a lot of money, and also you can also avoid underestimating the equipment in your grid or your investment. So give you actually a better way actually to foresee the risk and mitigate and de-risk your system. But also today, one of the things we observe, some of the limitation of today, RMS, I have no chance to see the aura, but at least what I see, there's a lot of challenges because the RMS, EMT actually have much better chance because actually it's able to replicate the actual implementations of the control in the field in a simulation. So actually you have, still you miss some aspect, but still you can capture as much as possible. RMS, lack of alignment with the actual implementations and a lot of simplification, that led to a lot of difficulty in deviation when operating system of the grid going to start. For example, if you see in North America and some utility in the region and in Europe, if SCR is less than 3, that can trigger investment in something. That, for me, this is a lot of waste of money. Sometimes you may need, sometimes you may not, but you have to have at least the model which actually it can give you more credit you can trust. This is very important when we're going to invest million and billion of dollars. And sometimes also, some of the problems, sometimes not the model, but also the experience of the user or simulation engineers actually try to over-interpret the result of the RMS solution beyond what the RMS simulation can do. This is also some of the issue. And to do so, actually, this is actually is a basic work. Actually, try to see actually what if actually if I align the implementation of my RMS model and control to capture as close. It's not perfect, but try to convert as close as possible to what you can do in EMT, and also actually what will happen if I include a negative sequence in the RMS model, how it behaves. This is the main core of my presentation today. And here, a simple, I need the pointer. Sorry. Yeah, I need the pointer. I cannot get the pointer. Okay. Yeah, if you see here, the top one in the figure A in the top is actually a simple VSC representation, and the figure B is equivalent circuit, which actually how we can model both as based on average model, fundamental frequency of average model, and that apply equally for the EMT and for RMS. And if you look in the figure C, if you want to control the converter going in the figure A, typically you control the converter relative to its PCC. But if you look in RMS, when you do a load flow, all the angle were measured from slack bus. You cannot control the converter from slack bus. So what you do, the figure C and D, try actually first, you will take the measure actually, you will take the voltage actually from the load flow, which is measured from slack bus, you to transfer it back to the PCC, there which is B, and then by doing so, actually, you use the control to drive the voltage at the converter terminal, then back to the slack bus. and the upper one, and if you see here, and this is the implementation in the top, and you can see there is positive, at the upper part is the voltage, and there is separation into positive and negative sequence through symmetrical components, which is by A here, and then the axis transfer to move from a D capital, a DQ capital, and DQ small, which is the global, the DQ, were fixed at the slack bus, and we move to small DQ where the DQ is fixed at the converter terminal in brief. And in this way, actually, you can model the RMS nicely, and that equivalent, if you have the EMT, when you put the PLL at the PCC, which actually is set to you reference voltage at PCC, almost like if you're solving a circuit, if you care at this point, my voltage is angle 0, is equivalent to that. So on this basis, actually, I can drive my RMS model, as you can see here in figure 3, and to link the AC side and this side, you can see here and there. I will not dwell so much here. And what we observe from the RMS model, we can see actually it can reproduce much accurate result, but that comes at the cost. Instead, it restricts you. If you do with this approach, it can produce accurate result as EMT. But the challenge you have, you actually, instead of having the speed, now you become much slower. But what happens if you get rid of, because my interest in the RMS, actually is to focus in the stability of the AC system, not to this side of that system. So what happens if I eliminate the inductance in this side or make it smaller, directly I can accelerate my simulation much faster again without compromising the accuracy of the AC systems, and also give me the capacity to extend the range of my simulations beyond what you can do. So actually, now I can actually use my simulation to do to comply with grid code studies, for example, to check if I can check negative sequence, I can simulate asymmetrical fault, much accuracy, and so on. And here a simple example, I think I'll just move. And here actually what I did a simple comparison actually to validate the model. I have EMT and RMS equivalent, the same operating conditions, even try to bring the control again as close as possible. And here a simple example, the upper one is the active power, and you can see the RMS, the reference RMS and EMT equally match, and the figure in the middle in the top is the reactive power, almost equally, with brief error and equally match, and the other one is AC voltage, and DQ current equally match, and AC voltage, the magnitude and instantaneous, RMS and EMT equally match DC voltage and DC current. And similarly, reactive power almost similarly match. I want to go here. And here is a case of single phase fault. You can see the single phase fault. In the other one, there's two columns. In the top, RMS, the EMT in the first column, and RMS. You can see the single phase fault. If you look in the figure D, in the column here, you can see one AC voltage collapse, the two up. But here, what I did, I controlled negative current to 0, which means the converter will inject symmetrical current. You can see the current asymmetrical in the RMS, the same like in the EMT, with the same accuracy. And in the other two columns, this is actually the RMS superimposed on the EMT. You can see all the DQ, everything is exactly matched as it is in EMT. And here also here is a phase fault. Also, you can see likely match as you can see in EMT. And I want to go here. This is very interesting here. And here, deliberately, what initially all the previous studies when the SCR system is 4. Here, deliberately, I brought the SCR or system to 1.5. And you can see, and deliberately, I try to increase the power gradually to see when the system will collapse, to see will the two collapse at the same time or not. And with the best tuning of the RMS and EMT, you can see they march until certain level, then the EMT collapse, then afterward, dance. Which means, yeah, actually, if having such model will give me opportunity to actually, even if I'm going to overinvest, you give a very small error in investment. And this is the kind of this is the kind of outcome you'll get if you have good RMS model. Actually, you will not overinvest, and you have more confidence when you do the study, or otherwise, today you have to redo most of the studies in EMT to check and all the things. But in this case, I can minimize the amount of work I can do in EMT. I think up to here, I'll stop here.
Thanks, Dr. Adam. I think we have completed all the presentations. We don't want to hold you for longer because there is a lunch break. But anyway, we have a chance for 10 minutes for the questions from the public. So please. Yes, can you give the mic?
From Hitaki, based in, sorry, I'm from New York, yeah. Yeah, because I'm familiar with
Give your name and the organization.
Araki, yeah, so in Grane, yeah, that's correct. Yeah.
Hello. Assalamu alaikum. With you, Ayham Al-Ghassani from Omantel. I am asking Abdul Aziz one question. For STATCOM, now STATCOM, it will absorb the current and will regulate the voltage. So we will have absorbing for reactive power. Is there any practical that it will absorb the reactive power, but what about the active power? I mean, can we, both of them connected to each other?
The STATCOM concept is, it's an IGBT-based solution, so it has, you can say, two modes of operation, capacitive or inductive. So in capacitive mode, you will inject reactive power into the system or reactive current into the system to raise up the voltage and absorb in the inductive mode, you absorb the reactive power to reduce the voltage. In the active side, this is for a normal STATCOM with only reactive power support. For active power support, you of course, as I said, you need a storage element. So you'll need supercapacitors or better energy storage system. And with this, for us here in enhanced STATCOM, we're using supercapacitors. They have the ability to inject and absorb active power into the system to regulate the frequency. And this is how it does it.
Thank you very much.
Yeah. Thanks. Who else? Yeah, we have one at the back.
Hello. Yeah, myself Anish from OQ Alternative Energy. This is regarding regarding STATCOM. When we are talking of grid forming capability, so can it give a black start capability also? Because I'm talking of an off-grid large system to support PV and wind generation.
To have black start, you'll need some sort of energy storage system. And based on the size of the plant that you have, you'll size the energy storage system that you need. But grid forming, as a control system by itself for a normal STATCOM, it will not have, of course, a grid start capability. You'll need the storage element.
So I think it holds good in case if my grid trips, then also my system needs a separate BESS supported system to be stable.
It is BESS or to size. This is what I'm saying. I mean, to size the storage element that you have for sure. Yeah.
Thank you.
Thanks.
Okay. Thank you. Yes, please. We have here the one in the front. Okay.
Thank you very much. Thank you very much for very nice presentations. If I may ask, because I heard that Hitachi introducing extended STATCOM with energy storage. I don't know if this is already available or not. And the general question maybe to the all panelists now, is it worthwhile to invest in offshore in Oman? Because I don't know if there is a possibility, for example, Siemens and Hitachi and HVDC systems could be good or not too deep the water. And other thing, what I was wondering, what about wave energy and tidal energy harvesting? So maybe the first question to Hitachi, and second to Siemens, and the last one to HVDC systems. Thank you.
Yeah. This is what we were talking about. We don't call it extended STATCOM, we call it enhanced STATCOM. Yeah, and it's already there. We have 2 projects under construction. It will be energized most probably in 2026, if I'm not mistaken. It's 250 MVAR STATCOM with 150 megawatts seconds supercapacitors. And it's in Germany, 2 projects.
This is related with the offshore wind farmers, or not just?
No, it's inland. It's inland, yeah. I mean, to decide on the right technology for the right location, right solution, you need to do the required studies in RMS and EMT as well. I mean, to choose, as I showed in the wheel for how to secure the grid, there's a lot of services there, and you need to find the right solution for the right location, do the enough studies, and know the rating that will support you there as well, and will meet the grid code requirements at that location as well.
Thank you very much.
Dr. Raf, would you like to comment?
I'm not sure I'm the exact right person to answer this because I'm not a geologist, but to the question on whether it makes sense to invest into offshore wind and into wave generators, I believe the study by the ministry to assess the entire landscape of where renewables is possible in Oman has been done over the last 2-3 years. And I think the conclusions mainly were shown today, right? So mainly the solar potential and wind potential. I don't know about the wave, to be honest. I don't know if anybody in the room can fill in here. I don't know if it's possible or meaningful or viable, let's say. For wind, I believe some of the offshore is planned.
Okay, thank you very much. And well, waves probably are possible here. There is some sea, like in Portugal.
Certainly possible, but I don't know if viable.
Yeah, thank you. Thank you. I'm asking you, Siemens and Hitachi, as far as I know, you are leaders, global leaders in, let's say, energy harvesting from everything, I would say. And thank you very much. And maybe HVDC system, what is your opinion according to this? It could be useful to use HVDC system in offshore or rather onshore. What is better?
Yeah, in principle, is it working? Yeah, in principle, actually, if you connect through subsea cable, because the far you go, the cable, AC cable has difficulty. You cannot transmit power over long distance. And also the amount of power it also poses some challenges. But this is why people, if you go offshore, far away, or even onshore, if a wind farm is far away from that, because, and also the policy in the country. For example, in Europe, because the DC has much higher power density per corridor than AC. So actually, in Europe, nobody wants to see bigger overhead lines. So this also, even within the land, if you're far away, DC more efficient. And also, DC give you a lot of flexibility. You eliminate a lot of STATCOM, synchronous condenser, all the things. It gives you much better opportunity. But if there is wind, offshore wind, because also, for example, I'm from UK, in the UK, because people don't want to see onshore wind farm. This is why all the wind farm push offshore, so nobody see the wind turbine, but you get the electricity. So there's driver doing that, but each country has its own policy. But in principle, today, I'm working for NEOM. Our grid is largely based on HVDC, and that for reason, especially in the area of renewables, because traditionally you can have maybe 3 stations will give you 5 gigawatts, 6 gigawatts. With wind, you have so many small wind turbines, so that in smaller area like Oman, you bring the risk of control interaction, instability issues, various problems in your systems if you connect through AC systems. But I don't know if you had an opportunity to go to Bahrain, you will see actually have some paper on NEOM grid, which actually deliberately designed to eliminate this aspect from the beginning. So control interaction, fault propagations, all these things localized, so in that way actually you avoid all this issue.
Okay, thank you very much. Just maybe at the last comment to this, because not only in Europe, probably also in USA, they are trying to move offshore with the wind farm, as far as I know. Maybe I'm wrong. Hitachi is delivering at least transformers to GE farm, but I'm not sure. I didn't make a research. And moreover, the Ørsted is investing in the Taiwanese offshore. I don't know if it is good direction or bad, but probably the desert is like offshore in the mainland, yes? Thank you very much, and sorry for a little bit long discussion.
Okay, I think we're coming to the end, because we have lunch break and there is another sessions. So, okay, in behalf of the IEEE administration, we'd like to thank the researchers and the presenters for their valuable contributions, and also would like to thank the audience for their interaction and for their attendance. Thanks again, and see you in the next session.
A small announcement, everyone, the lunch break is going to be at the ground ballroom downstairs, the lunch, okay? And please be back at 3:30 for the third session. And last session for the day today. Yay! And if you want to go home early, we will finish early, inshallah. Because I heard some complaints. People are annoyed because I'm pushing about the time. But I'm doing this for your own sake, so you can go home early. People, please be seated because we're about to start the third session and the last session for the day today. Yes, you. No. Okay, so our third session for the day today is distribution systems, and it will be moderated by Yusuf Al-Mahrouqi, Chief Technical Officer. Please welcome to the stage.
Thank you. Bismillah ar-Rahman ar-Rahim, and welcome back. I hope you will enjoy this last session. And I promise you that the team and the table have prepared something which is very fruitful and very enjoyable. Our session is mainly focusing on the distribution network. It will range from network modernization, resilience and reliability, also implementation of IoT, cloud enabled for load management. We'll also see the unit application for monitoring of medium voltage distribution network. Electric distribution network in Oman as a current context is one of also the good topic that will be presented. Overhead line optimization will be also one of the sessions that will be presented by the team. Without any further ado, we'll go to the first session, which will be presented by Gandhi-Raj. Gandhi-Raj is one of the expert engineer in Nama Electricity Distribution Company. He received his baccalaureate, master, and also diploma from India back in 2008. And he joined NEDC back in 2013 as a project engineer. Later on, he has been also moved because of his intensive knowledge and optimization in the design department. Today, he will be presenting his extensive experience when it comes to upgrading and modernization of the distribution network substation to enhance the efficiency, reliability, and resilience. Please welcome Gandhi-Raj.
Assalamu alaikum. Good afternoon, everyone. As we all agree, today we are facing a lot of challenges, especially distribution system design engineers, design department, who are handling the designs. So the first one is technology development. Every year technology is rapidly increasing. The next, power demand growth. The next one is the plot demand and real estate price. The next one, CO2 emission and sustainability goals. So I am Gandhi-Raj from Nama Electricity. Today I am going to be present how Nama Electricity handling these challenges, how we are making our network more efficient and reliable. The main objective of Nama Electricity is optimized design, smart operation towards sustainability. To meeting our objectives, I listed out key points, key areas, 8 key areas. The first one, sustainable PSS building designs. This is falling in the category of civil design optimizations. So the civil design optimization, there are a lot of factors are there. So here I listed out some of the factors which is relevant to sustainable design factors. The first one, plot selection, plot utilization, plot optimization, and how much percentage we are going to utilize mother soil, how we are going to reuse the mother soils, and our building, whether it is ready to meet climate changes like seismic factors, flood resistance, fire resistance. Apart from that, we are ensuring our building, maximum we are trying to utilize natural lights. And we are more concerned about the concrete usages, water usages, and its waste reductions. Apart from that, the main factor is our design mainly focused on sustainable materials and ICV materials. And finally, our civil designs, we are using the 3D modular design approach. The end, we are ensuring all our design buildings energy efficient building. This is one of our prototype of 3D design models. This is another 3D design model. This 3D design model, it helping us the execution stage. Normally we are facing a lot of interface issues between electrical, mechanical and civil department. All the interface issues we are avoiding by using these 3D design models. This is our final product. Earlier we build any distribution station. Normally it occupies 50 by 50 plot. Now by using this concept, 3D model designs, you can look the 50 by 50 plot, only 50% plot is utilized. The remaining 50% plot reserved for future expense, future need. The next category, digital signal transmission using IEEE 61850, which is falling in the category of digital substations. So while designing the electrical network, we clearly identified what are the equipment we are going to use, how the equipment they need to be speak each other, how we need to connect it with our control centers. We clearly identified individual equipment, what are the signals. We need to use hardwire, soft signals, 61850 or Modbus. So based on the input, we made the architecture drawings, all the equipment, how they need to be connected with our control centers. So finally, we made the summary. So if you are looking at the summary tables, almost 77% of signal we are using soft signals, IEEE 61850. Only 23% we are using hard wires. So by using the soft signals, we eliminated copper usage of coppers, pair wires, cable management systems, malfunctioning, almost everything we reduced. And as well as the CapEx, OpEx, both are reduced. The next category, MB switchgear with protection relays. Earlier, most of our network, till today, many of the utilities, other clients, they are using switchgear separate and control and relay panel separate. Now we introduced our switchgear, MB switchgear and protection relay, both are in same panel itself. By using this concept, my 33 kV switchgear and my relay panel, both instead of 2 cubicles, only 1 cubicle. So both the cubicle, so it eliminated more quantity of copper cable between the switchgear as well as the relay panels. So by using this concept, almost per cubicle we saved 6,500 reals. This is the capex point. Apart from that, a lot of OpEx reduction also. The next category, transformer orientation and ventilation, which is falling in the category of optimized, efficient and reliable network. So this concept in line with IEC 345. So that temperature and losses relations, the temperature and losses directly proportional. When the temperature is rising, my transformer core losses and total losses directly proportional. But at the same time, the efficiency of the transformer inversely proportional. When the temperature is rising, my transformer efficiency is going to fall down. By using this concept, earlier all our network, if you are looking at earlier design, the transformer orientation, mostly it faces east to south, east to west, due to the lighting requirement. Now our new requirement, we moved the transformer design, all 3 direction is fully covered, the orientation also north to south. So that means we are avoiding the direct sunlight and the orientation also completely we changed. The next category, 33 kV RMU instead of 33 kV outdoor gantry, which is falling in the category of optimized, energy efficient and reliable network. So most of our earlier network, we use the gantry arrangement. And now we are using the 33 kV RMU and 11 kV RMUs. So the gantry, is all the live equipment, breakers, CT, VT, all the equipment, it open to expose public and the high risk of safety concerns and remote operations. The SCADA control is a big challenge. By moving to the 33 kV RMU concept, it is very compact, low footprint, and SCADA control and operation and maintenance is very easy. The next, PSS lighting designs, so which is falling in the category of optimized, energy efficient design towards sustainability. Our earlier network, we used the existing system, conventional light fitting. Now we mainly focused, instead of the conventional light fitting, we moved to the LED. Yes, of course, everyone, we are using the LED. Our spec, we clearly mentioned it, smart LEDs, which is 60%, minimum 60% energy efficient LEDs. By using this LED concept, as well as we are using the motion control operations. So due to these complete changes, we did the case study for the seven of our stations. If you are looking at the stations, both portions is there. One is the indoor, second one is the outdoor. If you are looking at the indoor, the room wise, we did the calculations, how much it's consumed, and outdoor also. The 7 substation, the summary, if you are looking at the first 4 bar chart, it shows the old PSS. Old PSS, it consumes almost approximately 10 kilowatts. The new substation, after implementing the smart LED concept, it's consuming only 4 kilowatt, almost 60% is the power consumption. Due to the light change, smart LED, it reduces. The next category, PSS AC temperature setting at 24 degree, which is falling in the category of optimized energy efficient design towards sustainability. Yes, sir. We are using many equipment, many component, relay, switchgears, transformer, RTCC panel, everything. We have the doubt which temperature is suitable for all our equipment. So we check with all the equipment what is its best operating temperatures. If you are looking at the catalog, they manufacture, they clearly mentioned it, the operating temperature of all the indoor equipment, minus 25 degree to plus 65 degrees. Then we have the doubt which temperature we can set it in our stations, either 18, 20, 22, 23, 24, whatever. So we did the analysis, if you are setting the temperature in 24 degrees, how much we can save the electricity. If you are looking at the chart, it clearly mentioned it, if the temperature is 18 degree, and the old temperature 18 degree, the new temperature is 24, means almost 22% we can save the electricity. So the bar chart, it clearly shows the set value as well as the power consumption. The same thing we implemented in our primary substations. The 6 power substation, the earlier, when the set value is 18 degree means, it consumed almost 280 kilo units. After setting the 24 degrees Celsius, it consumed only 240K. Approximately 40K power units it reduced. Similarly for all the other PSS also. We did the average. When I am setting the temperature from 18 to 24 degrees, average one primary substation, we are saving 33 kilo units, which is equivalent to the commercial point, 1,600 real per year. In terms of CO2, 26 kiloton we are saving. In terms of TOU, ton of oils, 2.8 ton. This is for 1 year, one primary substations. Nama electricity, we have almost 700 plus substations. Just imagine, just calculate how much we can save here. The next category, AC water recycling systems. Yes, this is falling in the category of optimized energy efficient design towards sustainability. Yes, of course, all our substations, we require the water requirement. So now we did them in all our AC. See, we have the AC drainage. Why we cannot use the AC drainage for our substation usages? So we made the simple schematic diagram. See, we collected the AC drainage water and inline all the water purified. We started to reuse it for our substation requirement. So by using this concept, now all the stations, the external water source is completely eliminated. So earlier we paid almost 60,000 gallons per year. So if we are calculating in terms of CO2, 2.10 CO2 we avoided now. So CapEx as well as OpEx is reduced. So finally, yeah, I discussed the civil as well as the electrical. Net, how much we are saving. We did the case study in the 7 primary substations. The first 4 bar chart, it's for the duration of 1 year. The first 4 bar chart, it's showing the old primary substation. The bottom 3, the last 3, bottom is showing the new primary substation. If you are looking at the power consumption of the individual stations, it dropped down almost more than 50%. So this is a YTC capability statement 2023. 2023, the power consumption, energy consumed is 35 gigawatt hour. It emitted almost 27 million ton of CO2. In terms of TOU, 3 million ton. The same capability statement described in 2030, the Oman power energy requirement is 55 gigawatt hour. So that means it's going to be emit 43 million ton of CO2 and 4 million ton of TOE. Just we can, at least, we are implementing like this concept in our network, apart from the NAMA also. So 50% we are implementing, means at least 50% we are saving the generation, additional generation, as well as 50% we can reduce the CO2 emission as well as TOE. Yeah, conclusions. Yes, as a NAMA electricity, we proudly say our designs, our civil footprint, now it reduced to 50%. All our equipment, energy efficient, and the power reduction reduced more than 50%. Yeah, proudly we will say our buildings, NAMA's buildings are energy efficient, reliable, and relevant to the future need to meet our CAPEX and OPEX optimization, greenhouse gas emissions, and towards sustainability and NAMA ESG goal. Thank you all.
Thank you, Randiraj. Now we are moving to the next presentation about the resilience and reliability, a need for disruption risk management system at power distribution utility. Was supposed to be presented by Astosh Sharma, but now we are welcoming Mr. Mohanad Suhaili as a representative from DMV. Please come to the stage. Small introduction about yourself.
Yeah, good day everyone. Today I will be talking about disruption risk management within the distribution utilities. This is supposed to be presented by Mr. Astosh Sharma, but unfortunately he was unable to come here and do this presentation, so I'm doing it on his behalf. Basically, there are many factors that can affect the asset within the distribution utility and the substation that can increase the working load, can bring the substation and distribution asset in a high risk. And this is what we would like to touch upon. And this disruption management is basically well known within the supply chain management, but not within the energy sector. So I would like to reflect part of that experience to the energy sector here, and specifically to the distribution utilities. And what I'll be talking about today about the global temperature, global warming basically, severe weather and natural disasters, what is the impact of that, what are the characteristics of these disasters, and what do we need to do, what challenges we will face, and how to mitigate them. And we have created the basic element that may help the utilities to get familiar with and understand, to take care of. Now, what you see here, that is a record since 1975 up to 2020. And you see it is going in the wrong direction. It should be from that direction to my side. But you see there is an increase in the temperature globally. And this is a fact, unfortunately. That is a global, and if you see, I will take a few examples. This now the record for UAE, starting from 1901 to 2022. And what you see the record is increasing. Here we were about 27, and up to 2001, then it start increasing. So in general, it is increasing locally here in the GCC as well. Not only in GCC, this is a global phenomena happening everywhere. And what you see, this is a screenshot from DW, that is the German channel, and other resources as well, where they say it is a global. And if you read here, July 2024 was the hottest month ever has been recorded since they started the record 175 years ago. So it means global warming is there. We cannot deny that, actually. Now, DNV, the company I'm working for, they produce energy transition outlook, and that is almost every year. And this one is for 2023, where you see the first part, that is the record between 2000 and 2020, and the 0.6, 0.7, that is the average increase compared to the period pre-industry revolution in Europe. So here you see from there it is increasing, and what you see here, we all know about Paris Agreement, and that all countries should contribute, should reduce, and the agreed number is 2 degrees centigrade. That is from here up to 2050, 2100. And that is what they need to achieve. And if they want to do a bit better, they need to reduce by, or the increase should be 1.5 degrees centigrade above the record here, the previous record here. So the maximum they should achieve is here actually, that is the optimal, and the maximum should be 2 degrees centigrade. But if you see here, if we do, if all countries will meet their target for net zero, then they will reach 1.5 degrees centigrade by 2100. And most likely not all they will do that, so we will be beyond 2 degrees. We will reach out by, we will end up by 2.2 degrees centigrade in 2100. So there is a warming, global warming, we cannot prevent it. And 70%, the source of 70% of that global greenhouses are generated from the energy sector, unfortunately. Because of, we are basically told now, we are burning fossil fuels. The emission will be likely to fall only to 4% by 2023, so they will reduce it from the current limits to drop by 4% if they will do all, and by 46% by 2050. And that is about 16 years from now. Now, what does that mean? What is the impact? If we take another example, this is in Oman here, and what you see, that is the weather and natural disasters in Oman for the last 3 years. And in the top here, you see where the red dots are the fire incidents because of the weather, and the blue ones are the flood. And you see the number, that is the number of fire incidents. More or less, it is the same. And what you see here, that is the impact in square kilometer. You see for the last year, it was okay. And here you see there is a drop in the number, but there is the impact is way higher here. And for the flood, it has certain numbers, then it increase again and increase, and you see the impact is getting worse and worse. So it has a big impact if we take this example. And I think as we speak, there is a typhoon Pipinka in Shanghai at the moment. And this city, how many people living there? 25 million, I think, living in Shanghai. And it is happening there as well. And these are some pictures if such a thing will happen. So you will see roads will get cut, flood. It is a big impact. I have seen this in Oman. I was doing at that time in 2018 an audit, and I have seen the typhoon there. What is the impact of that? It was huge, actually, especially in the Salalah area, in that region. Now, this is another example about the impact, and this is the glove, they call it, and this is in India. This is a video. I think we don't need to see it, but what has happened, it is a lake, and the lake, there was a water surge, and the water surge has flooded the area, and there was a hydropower plant, 600 megawatt. It has completely been flooded and destroyed. And that is another impact to the electrical asset, in this case, generation.
Or a glacier lake outburst flood that swept through the Teesta River. The South Lonak Lake, which is a glacial lake in the upper reaches of Sikkim, burst. That's the starting point of the river Tista, Sikkim's biggest river. In fact, satellite images show how the lake shrunk after the outburst swiftly. This lake is about 17,000 feet above sea level. This is important because when it's a cloudburst or rain-related floods, the suddenness and magnitude is not as severe as in the case of a GLOF. All this water flowed down from 17,000 feet, wiping everything on its way to Sikkim's biggest hydropower dam, the Chungtang Dam, which is at about 5,000 feet above sea level. So for 12,000 feet, the water was flowing down in full force. This is the Tista hydropower project. The water with boulders, soil, and whatever else it picked up on the way just flowed into the dam, which couldn't withstand the ferocity with which the water was coming down. The dam burst and was destroyed by the sheer force. Chungtang was also the worst hit in Sikkim flood.
Yeah, that is another example. So it can happen anywhere to any type of asset. But what is the impact? What is the impact of that? So we have extreme heat. You know, just an example for transformer. If the temperature increased by 6 degrees, that can reduce the transformer lifetime by 50%, and that is impactful. And for the cables as well, you have ampacity, you have some calculation. If the temperature increases, you cannot load your cables as you're supposed to do, and that means you need to transfer less energy. So that is, again, impact. Now, there are many other examples. If thunderstorm, it will block cooling radiators, for example, and it will destroy outside asset where you put it outdoor. For the flooding, it will flood, it will shift complete. Cables, heavy cable, HV cables, I've seen them shifted like heavyweight objects because of the flood. And so on. And we have the lightning, which is increased, and other factors. Now, is this all? Is the weather impact the only thing we should take care of? No, definitely not. You remember the COVID. It was also impactful. If you want to do maintenance, you won't be able to run your maintenance programs, and that will impact your asset because of such a disaster. And now we have also the monkeypox. Are we ready to deal with that? If this will become like Corona? No, another one, cybersecurity. It has been talked too much about cyber and discussed cybersecurity during the first session. Are we ready for that? And a few months ago, there was the programming error from Microsoft, where airports, power plants has shut down because of this, the blue screen. Are we ready for this? Now, I think at the moment, we are not really ready for that. We have some emergency plans in place, but that is not everything. The characteristic of such disruption is element of surprise. It just happened, and then a short decision time, you need to act quickly, need for money, need to change, and also bigger threat for business. You just disconnect. You cannot supply your customers. What do we need to do, or what are the challenges? We all know the normal business management, where we have policies, procedures, everything, and the disruption management is completely the opposite of that. It is emergency situation. You don't have procedure. You need a large number maybe of assets will be affected. So it is a major. Okay. What do we need to do basically? We recommend, in short, to establish a disruption management policy, procedures, and risk register. And the key elements, for example, you see here, we put a few of them. I will not go in details. Philosophy and strategies, you need to be in place. Critical alarm selection of personnel. They will present to public, they will calm them down, they will guide your people, they will lead. Those people are a key in here. And then management resources, critical loads, you need to identify where to focus. Hospitals, military, municipality, other locations where you consider critical. And you also need to train your people for such situation. What more? What more? If this happens, then you really need to adopt your management, disruption management, implement it, review, learn from this event, implement the lesson learned, and then improve and find innovative solutions wherever you have challenges. So the key message here is get prepared, not for only weather conditions, get prepared for errors, for cybersecurity, for pandemics, for any other disruption that can interrupt your supply of power. And that's all. Thank you all.
Thank you, Mohammed. Our next session is about implementing a scalable IoT cloud-enabled electrical load management system for efficient and reliable EV charging infrastructure that adhere to the DNO power restraints, done by Mr. Deepak Rama. He is an expert in OT cybersecurity and automation specialist with an over 18 years of experience in substation automation system, OT security, and IoT. Please welcome Mr. Deepak to the stage.
Yeah, good afternoon. So today I will be talking about how EVs, the e-vehicles are changing the distribution network, how it is putting challenges onto the distribution network, and how an EV operator or EV charging operator can build substation, build the infrastructure so that he can effectively manage these load restraints that come from the distribution operator. So just initial idea, like why we are seeing more and more EVs being adopted across the world. 33% of all the energy consumed is by mobility. And out of this, the 20% of CO2 emissions overall is again by vehicles or mobility. It includes trucks, rails, passenger cars, and all those things. So this is something driving policymakers as well as personally, people make personal choices to go towards a more energy efficient, towards more green sources or green options for their mobility topics. So in this way, we are seeing that by 2035 across the globe, 50% of new vehicles would be EV. Even when we talk about public transport vehicles like heavy vehicles, trucks, we see that by it would be raised up to 30% in 2030. Year-on-year growth of the charging infrastructure will itself be 30% by 2030. So why is this? What is driving this? So as I said earlier, there are policies that are driving these changes. We will see some of the examples in the next slide. Like for example, Norway, they are leading this change. By 2025, all their new vehicle sales would be 100% zero emission vehicles. So they would not be selling any carbon, the traditional vehicles. They would be only selling passenger vehicles which are zero emission, like it can be hydrogen, it can be the traditional EV vehicles. So these are the possibilities. But you can see all across the globe that there are different countries have different targets, but this is the future, this is where it is going, this is the direction it goes. Even in Oman, the Ministry of Transport has committed a pledge of reducing the CO2 emissions by 30% by 2034. So this is also a target within Oman as well. So then that means you need to adopt new technologies, new mobility solutions. Now, what are the challenges when we talk about EVs? So the main challenge is you have as the more chargers come into place, we need more charging infrastructures because we need to charge our vehicles. So that means it affects the distribution grid because you will be plugging in, plugging out the cars. There is no control over it that what time you plug. Tomorrow when we talk about trucks being electric, trucks don't charge in an hour. It takes like 6 hours to charge. So that means there is load on the distribution network that how we can effectively manage the load on this infrastructure. Then there are limitations on the grid itself, the distribution grid itself. Distribution grid can only power as much it has. It cannot power more than that. So then that is another challenge that the distribution operator has. Upcoming challenges, as I mentioned, we need to centrally monitor all these different EV charging infrastructure so that we can effectively monitor and manage the load manage the load that can be distributed to the vehicles. Again, as I mentioned, truck charging is something that is very complex because it doesn't happen very quickly. In the future, we will also see that the charging stations, like for example in Europe, the petrol stations, they themselves have a charging infrastructure. So then in that case, they can also have their own PV plants. That means part of the power supply can be generated by themselves within their own premises using PVs, or they can use batteries to store the power that is generated during the day and then use it. But in the other cases, like when it is not sufficient, then they use the power from the grid. So then you need to have a system in place that can effectively manage this load distribution across the whole of the EV infrastructure that EV operator or a charging operator may maintain in his network. So what we have come up with, the solution is cloud-enabled or IoT and cloud-enabled solutions. So what it does is it takes data from the different sources, like it can connect to the chargers, it can connect it to, for example, for the medium voltage switchgear, the LV switchboards. So it collects the data, it is sent to a controller, and this controller is then connected to a cloud applications which can be accessed by the operator at any point of time. In addition to that, for example, the distribution companies like MEDC, Majun, they can send, for example, set points for the maximum allowed load current on a particular station so that this can be then effectively distributed to the different chargers in the station. So what are the use cases that at present we support? We have come up with a solution. So there are two main modules of the solution. So one is the dynamic load management, and then the second is the remote control. So first we will look at the remote control. So this is a particular case in Germany that one of the operator, he has a challenge that the software inside the chargers gets stuck due to maybe software error or something. So then they have to send somebody to the station to restart the chargers. So what we have developed is we can control the LV switchboards which power up the energy, the chargers remotely, and then we switch off and on the LV switchboard so that you can remotely operate the MCCBs so that the EV chargers can then be restarted remotely. So in this way, the customer has avoided like sending people just because a charger is stuck like due to a software error. But the main application that we are talking about is the load management. So when I talk load management, I will give you an example in the later on. The main thing is that the distribution companies, they set a target to every station. So this is the maximum load that at a point of time they can distribute to the consumers. So then in that case, there should be a mechanism wherein this, when more and more cars get plugged onto the network, it doesn't cross the limit set by the distribution operator. So then we have a controller. So in this whole network, we have a on-premise controller, which is basically doing the logic part. The cloud part is basically for monitoring and setting these values, but the whole intelligence of controlling the load, distributing the load happens at the station with our intelligent gateway that is residing within the station. So this is just an example. For example, a set point for a station may be 900 kilowatt. So, and if, let's say, the maximum charging capacity is 320 kilowatt, if there is one car, there's no issue. The car can be charged at the full capacity, like 320 kilowatts can be distributed to the car. If it is two, again, it's not an issue. But when the third comes into picture, you cannot charge it fully. Then you need to have a logic where you can distribute it. For example, one of the most commonly used use cases is equal share, right? So then you equally share the load between all the three charges at the same time. But there are other mechanisms, they call it round robin, so two cars charge at some point of time, and then next two cars charge, after that the next two cars charge. These are all different possibilities, so all these different logics can be implemented and can be set remotely from the IoT app that we have developed, so that you don't have to send an engineer to change the settings inside the substation or onto the charging station. Another important topic is when we are talking about assets. So we have assets like medium voltage switchgear, LV switchboard, EV chargers. Then the main topic is how are we managing the asset, like how are you checking whether the health of the asset, for example, you have a medium voltage switchgear. How are you monitoring that the health of this asset is good enough so that there is no issue that can come up in future? Because sometimes what happens is these issues don't develop in a day. It takes a time. For example, whoever is working in medium voltage, like they know that when we talk about arc flashes in the switchgear, it doesn't happen in a day. It takes a while for the condition to be developed. The temperature gradually raises, and then at one point of time it reaches a limit, and then it causes arc flash. But if we have an asset condition monitoring solution which can monitor these temperature increases or let's say insulation weaknesses before it really worsens, and give you an alert that in future maybe we will have a condition where the arc flash can happen, then we can carry out the maintenance activities before even that happens. So that means we need something like a temperature monitoring, let's say at the cable joints, humidity monitoring, because we know in this part of the world we have high humidity. We can install sensors for smoke detection, motion control. Somebody opens the door, like we have heard from many customers, distribution customers, that some people just open the door of the station, RMU station, and then steal the cable. So then we can have, to avoid that, we can have intruder alarms. And then again, as I said, we can do switching operations of the LV breakers remotely. So in this way, we can actually extend the lifetime of the asset in the substation. This is the future that we are looking at. At the present, as I said, we have a set point set by the distribution company, and then the load management takes care about how do you distribute the power. But in future, we would have PVs being integrated into the station, so that part of the energy distribution to the consumer would be with their own source of energy, or they can also use battery operated. Then in that case, again, the load management application should be intelligent enough to switch between PV or battery or the grid.
Large-scale solar farms, improvement of Malaysian PV interconnection guidelines to medium voltage grid, pilot demonstration project on the distribution generation management. Please welcome him to stage.
Thank you very much, Engineer Yusuf, for introduction. So thank you all for still in this room at this hour. So my presentation today is on phasor measurement unit, PMU, to monitor and manage a medium voltage network, integrate with a renewable energy resource. Okay, first I would like to introduce the organization that I'm working now. It's a Qatar Environment and Energy Research Institute. is a part of Hamad bin Khalifa University in Doha. It's a national research institute tasked with supporting Qatar in addressing its grand challenges related to energy, water, and environment. So we are part of Qatar Foundation for Education, Science, and Community Development. And in terms of power system activity, so especially my group, we are conducting cutting-edge research in the smart grid, microgrid, and other new technologies and solutions in power system, such as grid integration tool. And we are willing to share expertise and experience and open to collaboration throughout the GCC country. So in the slide, there are examples that we are developing. On the left, you see the PV grid integration tool. So we are creating, we use existing platform, Dick Silent for now, but we are planning to have similar tool that works on PSS SynCal and also PSSE. So this is one. Now the tool is able to calculate hosting capacity in distribution network for PV, and also we can do grid code testing, grid code compliance testing, and many more. And also we built microgrid, actually, 100 kilowatt microgrid, industrial microgrid in our testing facility. So we have PV, microturbine, and industrial microgrid controller. And also we have also microgrid we try to implement in one of the remote farm in the desert. So the picture on the right is the article published by Homer Microgrid, the software. Homer is a software developer for Homer Grid. And then on PMU, directly, what is PMU actually for power system? In transmission level, PMU is common, but what we are talking now is the application of this PMU in distribution, in medium voltage. So it's actually measurement device that will measure current and voltage, and then using signal processing, we extract the phasor magnitude for both voltage and current, and also angle. And the example of commercially available PMU I show in the slide. The left is the one that come with voltage sensors, current sensor together, and PMU unit, and also antenna. And on the right is a PMU. It is integrated to a switch gear. So this is the available PMU measurement device available today. And what distinguish PMU on transmission and distribution is, you can see PMU itself, it can be considered as advanced SCADA. So it is meant to replace SCADA, conventional SCADA. But what is the difference between PMU in transmission and DPMU for distribution is specifically designed for application in medium voltage, and it has lower cost and also a higher resolution. In transmission, the measurement can go up to 60 measurements per cycle, but in DPMU, it can go up to 120 samples per cycle. And on the right is an application that use PMU. What PMU is used for in transmission, I will not go in detail on this. But what motivate PMU application is the evolution of distribution network. Currently, can be considered is passive management, and the evolution is try to manage distribution network with active management. So basic SCADA will be changed to advanced SCADA, and all these DER, distributed energy resources, should be actively managed. And one of the areas that we try to address is improved monitoring, simulation, and control. And also, we try to have advanced distribution management system. And also, in terms of DER, it should be able, distribution operator should be able to adjust setting to manage network more efficiently. And in distribution itself, what PMU is meant, there are some evaluation done on PMU in distribution. So these are the potential benefit. So there is a ranking, which one benefit, which is high, medium, and low, and some research interest based on the specific application. So the one in green, that means the one that I'm focusing at this moment. And the red one is for something that has a lot of potential to be researched. We are from Research Institute. So the application, the benefit is high, but research interest is still low. So this is some issue that can be addressed using PMU in distribution. For example, load characterization. This graph on the left compared to load measurement from a feeder that has PV, one has no PV. So we can see clearly the green one has no PV, but the purple one has PV on it. And also for industrial in the middle, so we can understand, the utility can understand the load pattern with the PMU. And also, using PMU, utility can also understand how DER behave, because from the nameplate rating, probably not much information how fast the DER will inject the power. So from PMU, because of higher resolution, so we can see how many seconds it will increase power, etc. And on the bottom left, so we can also detect power quality problem. For example, voltage oscillation. So the purple one is from the feeder that has PV. We can see voltage oscillation in the feeder, and also power quality, other power quality detection, as well, such as harmonic, can also be detected using PMU. So one of the we try to demonstrate is fault management. Currently, at least this is in Qatar, when there is fault in medium voltage, it still depends on the complaint call for utility to know there is outage. And then the team will be dispatched, and they try to locate the fault using the equipment. But with PMU application, because we have measurement in real time everywhere, almost everywhere, when there is a fault, the system will automatically inform there is a fault and will pinpoint the exact location of the fault. So this is the project that we are having in Qatar, PMU pilot project. So this project is with Kahrama. So starting since 2019, we try to have this PMU installed. So, but due to many reasons, blockade was one, and then we had COVID, and then World Cup. So it impacted our project heavily. So only last year, 2023, end of 2023, we managed to complete the installation, and now it is commissioned. So, we went through a lot just to make sure this project completed. And then this is how this PMU is installed. It has to be installed at within switchgear. So you can see how it is attached. The voltage sensor is replacing the capacitor divider within switchgear, and also for current sensor, it is attached to the cable behind the switchgear. And this is just to share what we have from our monitoring system. So we have all the measurement of voltage and current. And in the system, in the distribution that we are using, we have 22 substations, but we only install 10 PMUs. But the measurement is coming from all 22, because the 10 is directly measured, but the other substation, we estimate the measurement using state estimation. So the whole network is observed. So the visibility is for the whole network. So we have the the figure show the voltage, the power, and also the current. And what we are not only doing this pilot project, but in the lab we are busy with innovation. So what we are trying to come up with is the new concept of distribution network management. So the idea is we try to extract all this information from PMU in real time. We feed it to a real-time simulator, and then we have digital twin inside real-time simulator. We simulate it in real time and also faster than real time to predict any disturbance that will happen in the system, and then we use artificial intelligence to detect many things, such as fault, or to do smart management, etc. And we also try to integrate the tool that we developed before with Disk Silent and also PSS Synccal to this system. And because this activity already started since 2018, so we had achieved, we are proud to what we achieved with provisional patent and also patent and also publication. And the pictures show the equipment that we have inside our lab. So in summary, PMU technology for distribution network is very promising to manage a distribution network in the future. And we have advanced research facility in this area. And probably we believe this installation is the first in this region. And we start to get information. Now there are bigger interest for this PMU in UAE and also in Saudi Arabia. So we are proud that we are the first to install this system in Qatar. But if there is a similar project in Oman, please let me know, because so far we believe we are the first to have this installed. And then we also conduct other research such as smart grid, microgrid, and other new technology solutions related to power system. And we always are willing to share our expertise, experience, and open to collaboration, especially to those entities within GCC region. With that, thank you very much.
Thank you, Dr. Mohammed. Our next session is about electrical distribution system in Oman, the current context and the key factor to the smooth energy transition. Presented by Engineer Saeed Lemshaikhi. Engineer Saeed has an over 16 years experience in the industry, especially in the utilities. He is like a professional in managing complex project, outlining objective and navigating challenge to attain a desired objective. His technical expertise is mainly in the project management skill and leadership experience, make an ideal professional in power system utility sector. Please welcome Engineer Saeed.
Thank you, Engineer Yusuf, for the introduction. I will try to make it short as soon as possible because I know most of you are already exhausted after a long day. Assalamu alaikum wa rahmatullah. Good day to all. I'm going today to share with you just a brief about the electric distribution system in Oman, current context, and emerging model with deployment of distributed energy resources. Just before start my presentation, I want to share with you my motives behind the work. Mainly two reasons. The first reason, I want to support the efforts undergoing by all sectors to support Oman's energy transition toward achieving the objectives of net zero emissions by 2050. And also the second reason, because if I'm coming from a distribution background, so I want to focus on the distribution sector to play a critical role with the transition of energy. As you can see, the contents of the presentation will be as follows. First, we'll start with the distribution system in Oman, an overview with the responsibility and the way forward. Then we will move to the conventional model of power system and how it is going to be changed. The third theme, I'm going to discuss the contribution of distribution systems to power sector transformation with the deployment of distributed energy resources. And the final or the last part, we will review together the critical or the key factors which should be considered while we are moving with the energy transition. And finally, I am going to conclude with the main points made in the paper. Okay, just I want to give you a glance on the distribution system in Oman. As you are aware, the distribution is the later stage after the generation and transmission. Here we have in Oman, the distribution business is regulated. It means the licensees, they are performing specific tasks under the regulator. We have two distribution or two companies are responsible for the distribution business. Nama Dufar Services for the south side of Oman and the Nama Distribution Company. They are responsible for distributing all electricity in all Oman, except some concession area. This involves operation, maintenance, and investment in the asset based on the growth, and also for the services for the supply of electricity. The voltage level ranges from 33 up to 450 volt inside the customer premises and supply electricity to different types of customers. Moving forward, now the current context of the distribution system, as already we have seen, the distribution business is regulated. It means specific tasks to be handled by the licensees as per the granted license. The good thing here I want to highlight the regulator in coordination with the distribution company, they realize the importance to review the current, especially the distribution use of system, and to make a reform to align with the energy transition. Just here I want to highlight two important points are expected from the outcome. There are a lot of outcomes, but just I want to highlight two outcomes. One is to review the current mechanism charge for the distribution utility for the incurred costs which for the services provided to align with the real cost. The second outcome also here I want to highlight, and it is related to my paper or our work today for the discussion, to ensure the boosting and developing a criteria, regulated criteria to incentivize the adoption of distributed energy resources and to lay the foundations for the utility to start their plan and implementation as soon as possible, which we are going to see here. First of all, now I'm going to share with you here in this slide and the next two slides the conventional model of power system and how it is going to change based on the incorporation of distributed energy resources. Let us first see the conventional or the traditional model of power system. As you can see here, left hand side in the screen, there is a large scale of generation. This is mainly from gas turbine power plants. And there is also a limited renewables, all these connected to the transmission. If you see the distribution portion, there is a limited, or there is nothing at all if we can just compare to other nations or other countries. All renewables are connected to the transmission line. So this is one direction of power flow, which we call it unidirectional power flow. So there is also no smart grid, no smart homes, and limited share of renewables. Now, moving forward, how the distribution sector is going to contribute positively with the power transformation. The simple answer, one solution is to adapt the distributed energy resources and incorporate these technologies with the distribution sector, with the distribution system, and also near to customers' premises. First of all, let us understand what are distributed energy resources. Distributed energy resources means a small to modular energy generating and storage system which provide electric capacity and also have the ability to provide energy generation where it is required. Okay, typically this type of technology producing up to 10 megawatt. So that's why we call it distributed energy resources. These technologies include distributed generation, like intermittent resources specifically, or mainly for wind and solar photovoltaic, and also other controllable renewable like CHP and like fuel cells. Also another type of this technology, storage system. It can come in the shape of electric vehicles, and also it can come in the shape of batteries. The third side of this technology, demand-side integration. Demand-side integration is a very, very important part in the distributed energy resources because it will comply, it will make it the system a comprehensive system. There are two types of the demand-side integration. One is the interruptible load, means that load which can be interrupted or disconnected at any time. Also another controllable load which can be also controlled by customers or by the utilities. This is the distributed energy resources which we need to incorporate and start to integrate with the distribution system. When we are going to incorporate this technology, the power model is going to be changed to adapt to the changes. You will see here now in the left-hand side, large scale of renewables in transmission. The main important thing here, you will see also renewables are connected to distribution system and with the customer's side. Okay, now we have the smart grid, we have the smart home. All these should be in place to ensure that we have all the capability of the system as we have a complex and sophisticated system. Now, let us move forward. Okay, after we incorporate these technologies, as a distribution system operators, we have to expect more or additional responsibilities beyond the traditional one. Yeah, we still regulated under regulation, but with the incorporation of distributed energy resources, we have to add some responsibility, like peak load management through the distribution energy resources. Also management metering, for managing metering data for small end customers. Also managing the congestion, network management congestion. Also, we have to start infrastructure of electric vehicles. Also procure voltage support and provide reactive power to the TSO. And this should be in coordination with the transmission system operators. These are the additional responsibility after we incorporate the distributed energy resources technology. Now, okay, what we are going to gain or to have a benefits from this integration? At least I try to limit to 3 benefits with the integration of this technology, we are going to reduce network investment using this technology. Means we are going to avoid or defer the investment in substation lines, even for distribution and transmission lines. Another thing, we are going to increase the flexibility with using the distributed energy resources, because we will have battery storage, we will have electric vehicles, we have demand-side integration. All these are going to contribute toward the flexibility of the distribution system and the grid in general. Also, the third point, leverage data to increase renewable energy penetration, because as you are aware, most of the renewable energy, especially here in Oman, are intermittent resources. So this is a very important point, and leveraging data, it will not come unless we have the AMI or advanced meter infrastructure. Okay. Now, okay, after, but before this, I mean now, to incorporate these technologies, I think we must have technical requirements, regulatory requirements, and also stakeholder responsibility and roles. As now more than 2 or 3 parties are going to engage with the distribution or with the power grid. Okay, let us just start with the regulatory requirements. I believe we have to mandate implementation of advanced meter infrastructure, also clearly defining the roles and responsibility of distribution system operators, TSO, also the owners of DERs, address cybersecurity requirements of all parties involved in this technology. Because now, at least now, currently, we have a limited renewable energy, but when we are going to increase these renewables, it will be uncontrolled unless we put clear security and cybersecurity arrangement in advance. Also, we need to incentivize this technology and make it in the track. Also, we need to review and make a clear signal to make the affordability for the customer, because the customer is no longer a customer. Customer is going to sell the electricity, and in turn also with this technology, he is going to buy the electricity to the grid. Data collection, management, and sharing rules of DSO. This is the privacy of the customers. This is a very important point. Moving to technical requirements also, we have to upgrade the current asset to be capable for sophisticated and complex system. Active network device, we have also to have tap changer, information and communication technology infrastructure, deployment of smart inverters along with the DER to avoid the disruption and interruption in case of a loss of a large resource of load. The addition of adaptive protection system to be capable to communicate in 2 directions. Moving to the last stakeholder roles and responsibility, we have to ensure a level playing field, transparency between all parties, securely share customer and grid-related data, better forecast. As already I mentioned, these technology, most of them are intermittent in nature. Also, distributed energy resource owner, they have to clearly share with the DSO information related to their capacity, location, and type of the energy used. In conclusion, I believe as we already started our journey, I believe we have to harness the opportunity assigned or the opportunity related to this technology, because the notion of centralized generation and the power flow in one direction will be no longer a solution. So we have to start and even start our plan and implementation as soon as possible, with taking into consideration the regulatory, technical, and stakeholder requirements. That's all my presentation, and thank you very much for your valuable attention.
Thank you, Engineer Saeed. We have started with primary substation optimization, and we are concluding with overhead line design optimization with Engineer Abdul Rahim Al-Saifi from BDO. Engineer Abdurrahim has a wide experience in oil and gas industry and specialized in overhead line design. He is a key player in BDO review and approval of overhead line design and standard. Besides that, Abdurrahim is involved in reviewing overhead line integrity and project with BDO, revealing for the latest solution. Please welcome Engineer Abdurrahim.
Assalamu alaikum. Assalamu alaikum all. Abdurrahim Saif, electrical engineer. Overhead line design optimization for distribution and overhead line system. We are going to discuss the challenge plus optimization in both sides. I will go through some topics in front of you. The demand of power going to increase yearly base because of residential and commercial sector increasing. This leading to requirement of power generation and transmission system. Transmission system for different vertical level, different structure, conductor, and different design. And the design is varied from area to area. For example, for a plain area, the design is different. We have to respect also non-plain area where we have to be with different UTS. Front of you, some overhead line facts. If we focus for first facts, already Engineer Muhannid discussed about the effect of the history of cyclone, weather condition. So part of the design for overhead line, we have to collect the wind history for last 30 to 50 years. As you know, in GCC last 30 years, there are a lot of heavy winds, some cyclones, a lot of structure in transmission distribution being collapsed and broken. This will lead us to focus really in coming project. Especially, you know, last cyclone, we have a lot of transmission line here, especially in Muscat and Batna side, being collapsed. Additional to that, in oil and gas, also we have many experience where a lot of distribution being collapsed. Second, we have to use the conductor, we should not give it more than 50% and less to avoid any more tension in the structure itself. The design criteria. The design criteria is the library of the design. We should give it all requirement, starting from international standard. We have to refer to specific standard like IEEE, BS, EN to design our structure. We have to give also wind terrain parameter, wind span and weight span, the sagging conductor, type of structure, type of conductor, fitting, all of this we have to give it in design criteria. The weather cases in GCC country, normally we give it the design between the temperature between 50 to 90 degree. We do simulation for all cases to get a conclusion where our structure will withstand with the most critical tension. And the average temperature in GCC and Oman as well, around 35 degree. And the wind velocity, we gave it normally around 38 to 45 meter by second. Here we'll go through the wind span and weight span, as well the overhead line clearance. You know the wind span is the clearance, the distance between the front span and back span, divided by 2, and the weight span is the lower point between the head span and back span, where the lowest point conductor we have to measure. And also we need to consider the clearance between the overhead line, new one, and the exist one, additional to the other, building or facilities. If you can see here, for example, the condition between structure number 3 and number 5, the terrain is, we can say, plain terrain, where the structure we maintain maximum span, basic span. And if we compare it with structure number 1 and number 3, it is non-proper terrain, where we should not go maximum basic span in this one. Here is a real example. Actually, there is one of the main challenge some, but not all consultants, they are utilizing not 100% of the structure UTS. In example number one, let's take, by the way, this is a real example. It is transmission line with 250 kilometer. We are using AAAC ALM conductor with wingspan around 350 meter and weight span around 880. You can see if we utilize 350 meter per span, we are going to total structure around 714. Actually, with respect to the different line angle, if we reduce 10 meter, 340 out of 350, we are going to increase around 21 structure. We are going to add around 21 meter. Again, with 330, 430 structure, 670, 20. The question always, as we overhead line specialist, we're asking the designer team or overhead line engineer, why you are not maintain 350, for example? They're saying, oh, we need to maintain safety margin. What safety margin? Your structure being designed with loading 100% for 350. Why you give it 90%? Why you give it 95? You should give it 100%. This, the loading being given to structure to maintain 100%. You should respect the design as which have already been type tested. Second example, for distribution system, for 33 kV, it's around 150 kilometer for ALM conductor, AAAC. The wingspan 100 meter and weight span 120. Again here, if we utilize 100 meter per span, we are going to use around 1500 structure. Again, if we reduce 5 meter only for the span, we are going to increase around 79 structure. Last one, let's say we reduce 20 meter, we are going to add around 375 structure. Imagine 375 structure for one overhead line, costing of structure, costing of installation, timing of the project, really very huge. Selection of fitting for overhead line system, one of the also critical points. Recently, last 2 years, and due to this adverse weather, we noticed there are a lot of fitting because of heavy wind, the conductor been broken. And in front of you, you can see the main data is UTS of hardware and fitting, the UTS of the conductor itself, and again, the standard where our fitting should be referred. Is it IES or EN or BS? We did RCA for one of our fitting, didn't clamp for 132 kV. The conductor was AAAC U conductor. The UTS for the conductor, as you know, around 141 kN. And the clamp design was 95 out of conductor UTS. The result was, you can see in the graph, sorry. If we count the 95% out of 141, which we should be around 135 something. But that is the fitting not passed the test. It was around 125 kN. Someone will say, but we are not applying 125. You are right, you are not applying 125. But your fitting should be aligned with the design and type tested. But here, unfortunately, it's not passed the test. Here we need to focus on selection, the fitting for insulator. Additional to that, could be sometimes the quality of the insulator, sometimes the quality of installation of the fitting. Next, right of way. Right of way, one of the main area we need to align it with the survey, during the survey, up to finishing the design. We call it the permanent and or land width. The designer team or the overhead line engineer should consider it during his design. We can see from right-hand side, during the heavy wind, the conductor is swinging, where it came right-hand side, this considered as right way. It's a protection for the human, for vehicle, for other conductor, if there's other conductor running parallel, to avoid the risk. And we can notice, because different overhead line going, there are a lot of, I can say, a reducing of right of way, which should not, this not supported. we should stick with the corridor for the overhead line on both sides. Recently, we introduced a steel ball for 33 kV. We introduced around 50 kilometer, 25 already completed for one project. There are many features for steel ball. We did arrangement for vertical arrangement with shield wire. We noticed there is no requirement for any cross arm, light structure. The basic span reach up to 120 meter. And the installation also very less comparing with the concrete ball. I expect here some of our local concrete manufacturers, they will not agree with us. But this already we did it. Second improvement or optimization, we did new design, front of you, if you can see left-hand side, 2 photos, with exist design with cross arm. Now we did improvement. We avoid cross arm because of bird strike. We have experience of heavy bird strike, and now we try to avoid it, the cross arm, for both steel ball and concrete ball. Also, right now we are doing study for cover conductor, where we are going to use messenger wire and spacer for 3 phases, plus the shield wire. It can be done for concrete and steel ball. And there are many features. You can see it's again short circuit, high UTS, and reduce the operation and maintenance. Here, if we focus on this insulator, if you have silicon, porcelain insulator, or glass insulator, plus sand, plus moisture, plus pollution, causing real flashover. The consequence, power outage, equipment damage, and could be also personal issue. Please, can you run the video, please? Here is the real case due to heavy pollution where the insulator failed. The traditional solution, what we are doing for insulator, for porcelain and glass, we are doing lifeline washing. Plus, we increase the cribbing. As you know, here in Oman and GCC mostly, it should be around 31 mm per kV, but we are keep it around 40. The new solution, we introduce here HVAC, high voltage insulator coating. We are using RTV, room temperature vulcanizing. It is material consists of silicon plus some fillers. We do coating for the insulator in temperature within 35 degrees. We keep it for a few hours. It avoids any short circuit and supports, the system against any issue. Here, similar the coating for the insulator, how we do it in full molecular. Also, the thickness of this coating is around 260 plus minus 5. Last, final recommendation. There are many recommendations for overhead line design. And one of them, we encourage all our consultants to do simulation for the wind from both sides. Normally, we notice most of them, they are doing design for wind only simulation from one side. They should do it from both sides. Additional to that, they should utilize the basic span for each structure. 100% should be 100%. In case you have 0 degree in your line. Unless there is, as I mentioned earlier, it is non-proper terrain. So in that case, we should maintain the UTS for the structure. That's all from my side. Thank you for your listening.
Thank you, Abdul Rahim. And I think since we are almost done in the time, we'll open directly the floor for the question rather than we have our own discussion. We have a lot of questions to really, but I think we give the priority to the audience. Please define your name and then again.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. هلال الهادي من نما للتوزيع الكهرباء. I am from Nama Distribution Company, هلال الهادي. My question to Basha Mahandis Abdul Rahim, just from your experience from video, do you have 66 kV overhead lines in the video system? And also, what's your experience, if it's valid?
Thank you for the question. We had one 66 kV overhead line, but already we demolished it. It was in service around more than 35 years back, and currently already we demolished. No more.
What reason? Only egging?
The egging, plus it was with the wooden bowl, we converted to, concrete bowl.
Oh, okay.
I mean, there is no more 66 kV.
Oh, okay.
The egging, yeah.
Okay. Also, just another question, sorry, Bashandas. When we add the coating for 33 kV, how much will increase the cribbage you expected?
It's around, let's say, the minimum requirement, let's say 260, plus minus 5%. Additional to that, it gave around 20 years plus warranty for the insulator itself. Also, the most of, clients, they purchasing the porcelain or glass insulator, and they doing coating before they install it. Some clients.
Okay, excellent. Thank you, Bashar. Thank you.
Assalamu alaikum. This is Asim from Doble Engineering from UK. Question for Mr. Mohannad from DNV. Excellent presentation, first of all. Really appreciate that. In your presentation, you spoke about disruption management. But obviously, due to the time, I understand it's generic. So what's the criteria for disruption management? Is it based on, for electrical industry, different voltage levels, number of failures? What's the criteria and what's the scale? If you can just help with this.
See, I will answer your question from different perspective based on my experience. I'm with this company for 10 years, holding the position as senior consultant asset management, and we are doing a lot of failure investigations, and we also train people for failure investigations. Now, if I reflect your question about when I should take care of my asset, whether to do investigation or whether to take care of this disruptive management, that will differ per utility. For example, distribution companies are smaller than transmission companies, and similarly, the value of their asset. A distribution transformer is smaller than a transmission transformer. So each company should define their own criteria, and that will be my opinion. But in general, they all should prevent major events similar to the ones we have seen here.
Thank you.
Thank you.
If there is no more question, I think we will, okay, there is one. We'll take the last one here.
Hello, Antonio from Up2 Energy. My question goes general for all. It's about how do you see the AI driving technologies on transmission, on distribution, on management, even on the design on the next 5 years? And also together with the AI driving technologies, the digital twin, how it will improve and help on the electrical transmission and distribution.
Would like to answer from the team?
Hello. Yeah. What we see is, as you rightly mentioned, AI is going to change the way we do operations, the day-to-day operations. So that means we see that more and more data collection technologies would be there in the substations. For example, we will have solutions to collect data related to temperatures, humidities, any other parameters within the physical assets. That's our transformers, that's our switch gears. So these data would be then, we would see that this would be data taken to central solutions where an overview of all the health of the asset, because many people spoke about how to extend lifetime of the asset, how to improve the efficiency of the assets. So in that case, these data-driven technologies would be more and more adopted. So we would see that at present, there are challenges with data connectivity, that integration of the physical assets to cloud or to central technologies are not very open. Like, people are still afraid of integrating these. But when more and more conference on the solutions comes up, we will see that different utilities, different industries start adopting cloud technologies, because AI on-premise, I would say it would be very expensive. So, in the long run, I would say that cloud solutions would be the future, and I see that the data usage for decision making would be seen more in the future.
May I also comment? I would like to share some experience from the SIGRA that has held last month in Paris, actually. And I have seen two examples. One example, they use it to this virtual reality, the glasses, they are using it to train their own people for the repair of overhead lines. So they have created a virtual classroom, and they are teaching the technicians or the engineers how to repair some overhead lines virtually. That is number one. Another example was I think from Siemens, they have shown two robots in the shape of dogs, and the one is little small, and it has been occupied with cameras and infrared cameras, and you can send it to AC/DC converter station where while they are in operation, no one can enter and access that. But this is little small one, so they will allow him to enter to capture infrared visual pictures as well, and also to measure temperature, humidity at different locations, define the location as well. Another example is a bigger one, and it can recognize the silica zone transformers and other activities. So you can put him on a remote substation, and then it will gather all this information, send it to the central, to the center where they monitor it or connect it, and then they can gather this data. And for that, they also may create some cloud to gather all these input virtually. So that might be an idea for the future.
Thank you.
I think with this, we have last question also there, and we will conclude.
This is for overhead line. Yeah, video. Just a question. What is the cost difference just by replacing an overhead line cross arm with a different terminology when we compare steel poles with concrete poles? What is the difference in the cost? And why do you want to move to steel poles when concrete pole manufacturers are available here? There are no steel poles manufacturers in Oman. Overhead line steel poles.
Thank you for your question. Actually, if you compare both structure designed with specific UTS, ultimation, but if you compare like to like, there is some advantage in terms of the weight of the structure itself, less, transportation less, the basic span more. So if you count the price structure, if you imagine you have 100 kilometer, if you compare it like to like, the structure on steel ball will be less. Again, if you count the installation timing, transportation timing, it will be different in terms of cost. For that, we introduce the steel ball. At the end, it is almost same or more, greater ultimate tension. We call it a UTS. For that, we introduce steel ball. We completed, as I mentioned, around 25 kilometer, and other project ongoing for other 25 kilometer.
That's interesting. You would like
with
to
vertical arrangement, yes.
See that study, because I still don't believe that steel poles can replace concrete poles. If you go strength-wise, only they are weight-wise they are lighter, but I believe in the long run they don't corrode, corrosion-free concrete poles. And you need a stay wire. I've seen the photo with a stay wire. You don't need stay wire for concrete poles.
See, if your design or simulation loading is the driver for this. You design it for 20 meter span as UTS, vertical arrangement with shield wire. You want to say without shield wire, sorry? No need?
I'm talking about the stay wire. You don't need stay wire for concrete poles, until unless it's a wadi crossing.
No, the design could be stay wire, could be OPGW.
Okay, you're using OP.
Yeah. So the both options are there. We complete our project with OPGW.
Okay, thanks. So cost-wise, you didn't mention what is the difference if we compare 25 kilometer?
We did some study, a study for this one. I can say with very, less angle. If you compare like to like, around 10 to 15% less.
Cheaper steel poles.
Saving, yeah, percent.
Thank you.
Okay, thank you to the audience, and I also thanks to my colleagues for their dedication and wonderful presentation. And I'm concluding with a small announcement that NAMA Electricity Distribution Company is also working with Absar to introduce something which is out of the box, where they call it solar community, or come together and invest, or also participate in, and they call it an investment project for a concentrated project location for, it's a very small, you are seeing between 1 mega to 2 mega maximum in the distribution network. This is a new introduction to the system. It used to be in the rooftop or in a big solar farms, but this introduction will allow also so many people, especially who have no access to the roof, like the people who are working or living in apartments, to rent and buy something, buy shares or contribute to the yield of those systems. The first project will be announced very soon, and we are expecting that a lot of potential investors will come soon in this regard. Thank you.